Welcome to the training program on fundamentals of Industry 4.0 and smart manufacturing. This program starting today will last for next 6 days comprising of technical sessions by industry experts. This is the third batch for training organized by FSM for National Academy of Indian Railways. Moving ahead with a brief about FSM. Under the Samarth Udyog Mission, Indian Institute of Technology, Delhi, and Automation Industry Association, supported by Department of Heavy Industry, have created a common engineering facility center that supports and develops technology for the Indian industry and helps with the right understanding and implementation of concepts of smart manufacturing. FSM imbibes technologies from leading companies in Europe, Japan, USA, and India, and offers an integrated experience for prospective users, consultants, integrators, and academicians. A brief about Samarth Udyog. Samarth stands for Smart Advanced Manufacturing and Transformation Hubs. Samarth Udyog is a national platform created by the Department of Heavy Industry, Government of India, for increasing the competitiveness in the Indian capital goods sector through smart manufacturing. I may now request Mr. S.K. Yagnik to light up the lamps and start the program.
Good afternoon and thank you.
A brief introduction about Mr. S.K. Yagnik. Presently working as Chief of Faculty Mechanical in the National Academy of Indian Railways. Welcome and address the participants, sir, for training program. Over to you, sir.
Very good afternoon. Professor Sunil Jha, Department of Mechanical Engineering, IIT Delhi, and Course Director. Mr. Naman Kapoor, IIA-FSM, and other team members from IIFSM. All the officials from Indian Railways, CRIS, DFCCIL, RVNL, who are attending this course. Ladies and gentlemen, नमस्कार and good afternoon to all of you. आप सभी का इस 6 दिवसीय ट्रेनिंग कार्यक्रम में स्वागत है. On behalf of Director General NAIR, National Academy of Indian Railways, it is my privilege to welcome all of you to this particular 6-day course on Industry 4.0 and smart manufacturing. I am happy to note that about 35 participants have come from all over the zonal railways, production units of Indian Railways, CRIS, that is Center for Rail Information Center, DFCCIL, RVNL, and the discipline from which they are coming is multidisciplinary, I would say, batch. It is indeed heartening to note that you have always shown so much of interest in this subject, and whenever this particular course has been conducted, there has been a good response from all over the country. While the theme of the course is centered on Industry 4.0 and smart manufacturing, this course is poised to take us to the realms of IoT, various areas of automation, data analysis and visualization, condition monitoring, and predictive maintenance, as well as additive manufacturing. I'm sure this will be useful to all of you. It is going to be of interest to all the stakeholders cutting across the entire spectrum of discipline which is serving Indian Railways as well as all the PSUs. The imperative of keeping such a program concurrent and relevant is paramount, and keeping this in view, AIA Foundation for Smart Manufacturing and has were requested to design the course. I am indebted to Professor Jha, IIT Delhi, and Mr. Naman Kapoor, IIFSM, who have accepted our request and who have taken great pains and care to design and plan this course in details. Over last week, 4 weeks, we have been in touch, and I'm sure that this entire 6-day program will be of immense relevance to all of you. As you know, gentlemen, railway's primary role is that of a transporter in both freight and passenger segments. And the customer, who is the end user of services, expects a safe, comfortable, and reliable services which are economical to him within the technological envelope of the railway transportation as it is offered. The application of technologies becomes important in this context, and that is an enabler, and it very much translates the basic framework of transportation system into an intelligent carrier delivered in most precise manner, in a safe manner, and keeping the reliability and safety in mind for achieving the highest indices of efficiency and effectiveness with least cost. 4 themes basically summarize the lean manufacturing. They are interconnection, information transparency, the technical assistance, and decentralized decisions. The smart manufacturing is a broad category of manufacturing that employs computer integrated manufacturing, high level of adaptability, and rapid design changes, digital information technology, and more flexible technical workforce training. All that will be coming to you over the various sessions which come up. I'm sure about that themes must have been planned. Industry 4.0 and smart manufacturing have started making inroads into the Indian manufacturing sector also. Real estate as well as Indian railways have also made a beginning in this sector. Digital innovation and artificial intelligence, data analytics, robotics, and 3D printing, as well as the rapid prototyping are transforming the global manufacturing landscape in abroad as well as in India. And none of us can ignore this sector if we want to remain vitally competitive. While all the participants present here will gain in some way or the other insofar as technical skill upgradation is concerned, however, at the end of the day, the learning can be quantified as value added only if it translates into the high customer satisfaction to our customers, which is passenger and freight segment. I'm sure there are engineers from signaling, there are IT professionals here, mechanical engineers, and all of you will be able to take the knowledge which you acquire during these next 6 days into your working areas. Therefore, while learning the nuances of technology, my humble request to all of you is to be constantly pondering over the themes and possibility of application of these sessions in the work areas where you are right now posted, so that you can produce or maintain the assets on which you are deployed to the most effective manner, in safe manner, comfort, productivity, or all these factors combined can also be area of your application for the theme that is going to be rolled out. I would request the participants to make full use of this opportunity. There is one more humble request, that when you are delving into these subjects, you may get some calls from your bosses, your superiors, to attend to some sundry work, because online courses, one of the drawbacks is that your superior may believe that you may spare 10-15 minutes or half an hour for his urgent work, but kindly at this stage, at least for the second half when you are engaged in courses, kindly tell your superiors to let you off for this course completely. If you find any problem, please let me know. I'll be speaking to them so that I can ensure that you are able to maintain full attention to the sessions which are going on. And believe me, friends, if you miss one link, one small link, you may be having problem in connecting all the vital poles of this particular theme, that is industry 4.0 and smart manufacturing. तो आपको यदि कहीं भी लगे कि आपको अपने वर्क एरिया में आपको सीनियर से कोई कॉल आ रहा है, आपको डिस्टर्ब किया जा रहा है, मेरे को कृपया ग्रुप पे बताइए. my humble request is we are taking a lot of efforts. IIT Delhi has spent a lot of time in designing this course. This effort should not be going waste. This is a one-time opportunity for you to learn the technology. Application, yes, it is a lifelong, I would say, dedication, but learning them first time, first hand, when you can ask any silly question to the panelist without feeling any hesitation, because of course you are being brought here for the first time. This kind of opportunity may not come very often. So with this request, I thank the team of IIT Delhi, IIFSM. I thank all the participants who are present here. I wish a very, very happy learning to all of you. Have a safe and comfortable, I would say, period in the next 6 days, because COVID is rampant. Every other person is getting caught. So I hope all of you will be able to maintain your single-headed focus and will be able to devote your time and energy. The project which you select at the end of the session should also be relevant to your workplace, and probably if you can go back to your offices and apply some of them, I think that would have served the purpose. With that, I thank all of you. I hand over the stage to the organizers, and I'll be constantly there from time to time. I have to manage one more course right now, but I'll be in from time to time. I'll be coming in and out of the course. Thank you. Thanks a lot.
Thank you for motivating and enlightening the participants, sir. I would now request Professor Sunil Jha to take over for the technical session on Industry 4.0 and smart manufacturing technologies. A brief about Dr. Sunil Jha. Professor Sunil Jha did his PhD in manufacturing science from IIT Kanpur and has been engaged in teaching and research on manufacturing processes, computer-aided manufacturing and industrial automation since last 13 years. He has developed a new unconventional super finishing processes and filed 8 patents. Few of them have been successfully commercialized. Before joining IIT Delhi, he worked with Tata Motors, Jamshedpur in the area of CAD/CAM and was engaged closely in digitization of engine components and foundry tooling development. Currently, in the capacity as Director, IITD-AIA Foundation for Smart Manufacturing, Dr. Jha is closely supporting manufacturing industry in absorbing new technologies to make them ready for next industrial revolution. Over to you, sir.
Thank you so much. Very good afternoon to all of you. And I must thank DG NAIR for giving us this opportunity third time. And certainly the efforts made by the Chief of Faculty Mechanical, Mr. S.K. Yagnik, is commendable, that we'll be again interacting with you, the railway officials, third time for taking up this course. So it's really wonderful. Last 2 times, I certainly would like to mention that I enjoyed thoroughly when we conduct this course, the way the you learned guys are interacting with us during the course. We always find this in a very interactive and the two-way beneficial to each other, actually. That is what I look forward. Certainly, we are working more on the research and development of these technologies. And all of you are in the field and trying to implement some of these technologies at your respective place. So that's really nice to have you again in this session. And I look forward that the next 6 days of engagement with us will be fruitful to all of you. I would always like to have this course as informal as possible. So wherever you feel you have a doubt when we are discussing something, please feel free to raise your hands and then interrupt us so that we can have a mutual discussion. So before I take up session further, I would like to at least have a quick introduction of the participants, and I would like to at least have, if they can just make their camera on, introduce themselves, a brief about where you are and what kind of manufacturing activities you are engaged in. That will be really nice, and then we'll take up forward the technical session. So I think let me just read out the names from there, then we can start. Yeah, so we can start with a brief introduction from Mr. Alok Kumar Mishra.
Yes, I'm Alok Kumar Mishra. I'm a mechanical engineer, and I have completed about more than 20 years of service in Indian Railways. I have been associated with various different arena of mechanical engineering in railways. So I have dealt with machines, electrical engines, and coaching depots, workshops, and all those areas. Presently, I am working in an organization, Rail Vikas Nigam Limited, who is dealing with mainly turnkey projects of Indian Railways. So, we have installed one complete bogie maintenance disassembly and assembly unit, which is having Internet of Things and Industry 4.0. This is my brief background.
Thank you so much. It's really nice to hear from you that you have already initiated some activities in this direction and successfully taking up those projects. Thank you, sir. Thanks for sharing your experience in this. Anmol, UK.
Good afternoon, sir.
Good afternoon.
I am Anmol UK, working as a works manager. I am mechanical engineer, 2016 batch. I am mainly focusing in workshop production of wheels and bogies, LHB bogies and ICF bogies. Thank you.
Thank you. Thank you. Anil Jagtap.
Good afternoon, sir. Myself, Anil Jagtap. I am working as assistant works manager in Kota workshop. It's mainly dealing with repairs of wagons. In this workshop, in wheel shop, we are having machines that are connected with an Industry 4.0. So we are monitoring all our machines with this system. Thank you.
Thank you, Anilji. I think it's really nice that you have also initiated this. So for me, it's really exciting to know that this journey that of this interaction through this course, we started, I think, almost 3-4 years back. And first time when we are having this batch, we may not be having so many use cases being implemented, because last 5-6 years, I think there a lot of development has happened. And now I'm happy to see that almost all of you may be having some kind of an hands-on and start journey in the Industry 4.0 implementations. That's really nice. Apurva.
A very good afternoon, sir. So, am I audible, sir?
Yeah, you are audible. Yeah.
Very good afternoon, sir.
Good afternoon.
So, I belongs to Eastern Railway. I'm working as a Deputy CME General at Kachapara Workshop, sir. We are basically into the maintenance of EMU coaches and memo coaches, sir. I'm looking after the maintenance of EMU coaches, motor coaches. I'm also looking after the maintenance of wheels of different type of locos, EMU, memos, ICF. There, I'm also looking after the maintenance of various parts like spring, vertical dampers, etc., etc. The Industry 4.0 is being installed at my wheel shop. It has been connected to the 3 machines, that is surface wheel lathe, press machine, and a boring machine. So I think 1 month before, this has been installed in 3 of the machines. So I will looking forward to implement the whole the application of Industry 4.0 and how I can monitor the progress of this machine and how we can improve the working of these machines.
Thank you, Apurva. Ati, thanks for this input. Next, I request Mr. Ashok Kumar.
Sir, good afternoon.
Good afternoon.
Sir, again, another mechanical engineer. Almost 9 years into railway service. Sir, I'm currently posted in Bhavnagar workshop, which comes under Western Railway. Basically, all workshops, they are doing the same kind of work. So we are maintaining bogies, we are machining wheels, and we are maintaining coaches, LHB as well as ICF. So I'm lucky that I'm part of this course, and I'm looking forward to get learning from this course. Thank you.
Thank you, Ashokji. Thank you. Looking forward, certainly. So next, I will request Mr. BK Roy.
Good afternoon, sir.
Good afternoon.
Sir, myself BK Roy. I am working in Rail Vikas Nigam Limited. as GM Mechanical and posted at Kolkata. I am basically involved in planning of workshops, where basically we are doing workshop projects in turnkey basis and fast track manner. And my association in workshop projects are planning for that, freezing drawings and specifications, and installing all these machines. So far, I have not gone through this industry 4.0, and I have very little knowledge on that. I will wish to learn from this concept from you, sir.
Thank you, sir. Thank you. Certainly, we would like to at least take you through a quick journey on this Industry 4.0, whatever we have learned and whatever we have understood till now. Yeah, really nice to have you. Thank you,
Thank
sir.
you, sir.
Thank you. Next, I will request Bharat Singh.
हेलो गुड आफ्टरनून बॉस
Good afternoon.
मैं भरत सिंह सीनियर ईडीपी मैनेजर रेल कोच फैक्ट्री कपूरथला एंड आई एम इन्वॉल्व इन मेंटेनेंस ऑफ डाटा सेंटर server system networks and also was involved in development of software applications in Oracle based platforms. Thanks.
Thank you, sir. Thank you. Really bring out good IT experience that you have been till now. It's really nice. Okay. Next, I will request Mr. Durga Prasad Mishra.
Good afternoon, sir.
Good afternoon.
I am DP Mishra, Deputy CME Wagon Shop, Vallaburi, to Visakhapatnam. This is just a new workshop, started just 2 months back, and I am just monitoring the periodic overhauling of the wagons. We have no exposure of the industry 4. I am glad to learn from you, sir. Thank you.
Thank you, sir. Thank you. Thank you. Okay. Next, I will request Mr. Jugal Kishore.
Good afternoon, sir. My name is Jugal Kishore, post IIWM bogie in RCF. Right now, I'm looking after the production of bogies. Thank you, sir.
Thank you. Thank you. Next, I will request K. Kailash at DFCC. Yeah.
I'm K. Kailash, working as manager IT DFCC here. I'm currently looking after SAP HR and HR related and finance related implementation, and I have been with the IT industry for now around 20 years.
Okay. Thank you. Thank you, Kailash. Next, we have Kumar Saurabh.
Good afternoon, sir.
Good
My
afternoon.
name is Kumar Saurabh. I am working as a workshop manager in Kharagpur workshop and mainly looking at conversion of coaches into railway camping coaches, NMG coaches, ART, RME, all the RSP work related to it.
Thank you. Thank you, Mr. Kumar. I will request Mithilesh Kumar. Mr. Mithilesh Kumar, are you there? Okay, we'll move to next. Mr. Mohit Mandlekar. Sorry.
Good afternoon, sir.
Good afternoon. Good afternoon.
Sir, this is Mohit Mandlekar. I am working as Senior Division Mechanical Engineer in Bhusawal Division of Central Railway. I am basically looking after maintenance of different kind of rolling stock, including wagons, coaches, and we have ART, ARMVs, then MEMU, all kind of rolling stock we have in our division. We are basically looking into the basic maintenance of those rolling stocks. Thank you, sir.
Okay, thank you. Thank you. Next, I will request Mr. P. Ramachandran.
Good afternoon, sir. Myself Ramachandran, I'm working as a Deputy Chief Mechanical Engineer, planning at the Central Railway Headquarters. The overall duties for planning for the works and the various machineries for procurement and their operation. Thank you, sir.
Thank you. Thank you. Mr. Mithilesh Kumar, yeah, I can see you
Yes,
now.
sir.
Yeah,
Yes,
please.
sir. Good afternoon, sir. I am Deputy CME ELF, Electric Loco Fabrication at CLW Chitranjan. I am looking after the work of cell fabrication, loco shell fabrication. In my shop, fabrication of loco shop and manufacturing of loco shell is being done. Thank you, sir.
Thank you. Thank you, Mithilesh ji. Thank you. Next, I can see the name PM/M. Please introduce yourself here. You are on mute. Just unmute yourself.
Good afternoon, sir. My name is Jagdamba Prasad. I am a mechanical engineer working with Indian Railways from last 8 years. I am posted in Dahod, Gujarat as a works manager. I'm looking after maintenance of freight stock, basically.
Okay, thank you. Next, Mr. Prasenjit Kumar.
Good afternoon, sir.
Good afternoon.
Sir, I am Prasenjit Kumar, posted as Deputy CME Manufacturing, Jamalpur Workshop, sir. I am looking after manufacturing of box and axle wagon, and BRN wagons and BLCS wagons, sir. Thank you.
Okay, thank you, Prasenjit. Next, I will request Mr. Rahul.
Sir, good afternoon. Sir, I am Rahul Meena. I am currently posted as a works manager, Modern Coach Factory. Sir, I am looking after production of LHB shells, complete shells, sir, from beginning to the end, like and various sub-assemblies also, sir. Sir, in Modern Coach Factory, we have Industry 4.0 in wheel shop. So that's it, sir. Thank you, sir.
Thank you, Rahul. Thank you. So we have next Mr. Rahul Medhane.
Good afternoon, sir. This is Rahul Medhane from WM Carriage Works Perambur from Southern Railway. Sir, we are carrying out POH of various ICF and LHB coaches and POH of wagons also. Thank you.
Thank you. Thank you. Next, we have Mr. Rahul Mishra.
Good afternoon, sir.
Good afternoon.
Myself Rahul Mishra. I am currently posted at Lucknow, Northeastern Railway. We are mostly doing the work of maintenance activity of the related to coaching as well as freight stock. Basically, we have the one Arway depot where we are doing manufacturing work like tire turning and manual welding.
Okay, thank you, Rahul. Next, I will request Mr. Rajesh Gupta.
I am General Manager in CRIS at the moment, and presently I look after the development of applications related with office automation, collection of data from various applications which are developed for railways, and then collating data, making dashboards, doing some descriptive analysis, and trying to do predictive also. Beginning there. And earlier I have worked with railways in the area of signaling and telecommunication, having designed systems and executed various projects related to signaling and telecommunication. Thank you.
Thank you, Rajesh. I think you have a very apt experience, and at least you are already working to a great extent in the domain of Industry 4, because you are dealing with the data and the IT system. Very important. Thank you. Next, I will request Mr. Ram Prakash Khare. Sir, you are on mute. We are not able to hear you. Still, we are not getting your voice. Maybe something wrong with your microphone.
Now, am I audible, sir?
Yes, sir. Yes, you are audible.
Good afternoon, sir. I am Ram Prakash Khare. I am working as Assistant Works Manager at Coach Factory Bhopal. And here I am looking after the wheel shop we are having 5 CNC machines which are connected by Industry 4.0. I am basically electrical engineer. I have done my BTech from Gwalior. Thank you, sir.
Thank you. Thank you so much. Okay, we'll move next. Mr. Sarveshwar Yaduvanshi.
Good afternoon, sir.
Yeah.
Sir, myself, Sarveshwar Yaduvanshi. I'm currently looking after the post of ADME demo and ADEE coaching in Ijitnagar division of Northeastern Railway. I look after the maintenance activities of demo trains and the train lighting and air conditioning system in ICF and LHB coaches in Ijitnagar division. Sir. Thank you.
Thank you. Next, Mr. Siddhant.
Good afternoon, sir. So my name is Siddhant Verma. I am Works Manager Wagon at Kharagpur Workshop, Southeastern Railway. Mainly here, sir, I am looking after the periodic overhauling of wagons. Here we maintain bogies, wheel turning, and other things are carried out. Thank you.
Thank you. Thank you so much. Mr. Suryakant.
Good afternoon, sir.
Good afternoon.
Currently, I am posted as Deputy CME Sanpada in Central Railway at Mumbai. We are looking after a regular periodic overhauling of EMU, that is the suburban trains of Mumbai. Thank you, sir.
Thank you so much. Thank you, Suryakant. Yeah, so as per my list, I have covered everyone except one, I think WM.MTC3. Sir, if you can introduce yourself.
Yeah, good afternoon, sir.
Good afternoon.
Myself, Abhay Sahani. I am basically from IT side network, but recently I have been transferred in plant department in RCF for establishing of Industry 4. We are in the process of establishing that.
Okay, thank you so much. Thank you, sir. Anyone left out in the group? I have almost.
Yes, sir. You have missed me.
Yeah.
My name is Utkarsh. I am from 2001 batch of IRSME in Railway Service of Mechanical Engineers with 18 plus years of experience. Right now, I am leading a small team trying to implement an IoT-based, RFID-based automatic rolling stock track and trace system at CRIS. I'm here in CRIS for the last year and a half trying to do that.
Okay.
And plus, we are also looking forward to implementing direct part marking, which I believe would come in useful for in some aspects of Industry 4.0 in Indian Railways. I did my mechanical engineering from SCRA, that is Jamalpur, with BIT Misra as a twinning program. And I also have completed my master's in public policy and management from IIM Bangalore. I also have a degree in post-graduation degree in economics. So I think this course will be really useful to me to try to implement some of the learnings at least. Thank you.
Thank you, sir. Thank you. Thank you, Percy. Anyone else left out for the introduction? So fine. Thanks. Thank you so much. I think it's really nice to hear all of you and get to introduce with yourself. And most of, I think, participants I found, they are dealing with maintenance activities. And I really appreciate because you have already started some kind of initiative. I think certainly the kind of an awareness that has been generated about Industry 4.0 is something which is keeping us in the direction of implementation of these new technologies. And certainly during this course, I would like to take you through the quick journey on the various technologies, various aspects of this Industry 4.0 and smart manufacturing. With this, let me start my session for today, and I will be at least briefing about the course, and then I will move to the technical session. Good. So this online training program is on fundamentals of Industry 4.0 and smart manufacturing. And as you might have seen at the background of mine, there are two institutions of knowledge that I have put them together, NAIR Vadodara and IIT Delhi. And this course is certainly kind of an understanding between the two institutions that we would like to share the knowledge and learning that what we are going through to all the participants from the NAIR and the railways. So we have already gone through the introduction of the participants. I will quickly give you the course overview. So in this 6 days, we have planned the course in this structure. So we will be having these live sessions, and we will be starting with today's live session. The technical session is on Industry 4.0 and smart manufacturing technologies, a quick overview of the activities, what we are doing. And then post break, we'll have a session on convergence of automation and IIoT, which I will be continuing along with the first technical session. And then we have a invited talk from an industry speaker on the smart connected manufacturing. He will share his experience of implementation of the smart manufacturing. Then we will be having a quick briefing about the course project, which is a very important part of the learning that we will be going through in next 6 days. So from the day one, you have to start thinking in that direction. So we'll have a speaker from industry who will be briefing you about the course project. So this is all for today. A very important point Mr. Yagnik had made during the briefing session, that it's very important to be present during these sessions. That is because these all topics what we have chosen, they are interconnected, and then they are not going to be repeated again. So we are just touching upon all the topics which are relevant to the smart manufacturing. And if you missed any of the link in between, certainly it's difficult to follow up the complete picture of the implementation. So that is very important. So please try to be attentive and focused on these interactive sessions. And I will also brief you about the additional material that we'll be making you available apart from these live and interactive sessions. Then tomorrow we will be having a session on smart sensing, because sensing is a very important component or element and which is a data source basically for Industry 4.0. So if you see in the smart manufacturing, everything is talking about the data, and the source of this data is starting from the sensors. So we'll be having this session on smart sensing. You'll get to know about the advanced sensors which are there and helping us in implementing this smart manufacturing concepts. And post the break, we'll have a session on smart machine concepts and the technologies, because we will be talking about the smart machines, what should be the characteristic and feature of these smart machines. And we'll try to give you a quick demonstration of that also. Then we will be having a 2 days break, and that has been intentionally planned. So this course has been planned that we will be starting before the weekend, and we will be taking you next 3 days, 4 days after the weekend. So these 2 days in the weekends are certainly very important for this course. You have to go through the course, that e-learning material that will be provided to you. And some of you already started logging onto this website. I will brief you about that as well. And then you'll start thinking about the project part. So that's a very important element, as I was mentioning, that you need to start thinking of all the technologies we will be talking about in this course, how you can see them, their implementation, their applications in your area, wherever you are actually, in whichever sector you are working on. So after these 2 days, we will be taking you to the another important technology which is useful in the smart manufacturing, is the augmented reality. And because as I see most of you are working in the domain of maintenance, how the remote maintenance can be guided through the technology of augmented reality. So we'll have a session on this. We'll also give you a little learning and demonstration on how these kind of technologies can be implemented. So whatever we are implementing in FSM, we will be sharing that learning with all of you. So we'll give you a quick demonstration of the augmented reality implementation and the kind of possible applications. After that, I will be taking this session on data organization for visualization and analysis, because as I was mentioning in the smart sensing, you will be getting a data that is coming to you. But then most of the time when we heard people implementing Industry 4.0, they will be getting data, certainly because they have already started the basic implementation activity. But once you get the data, how you will be making use of that data is a very important part here. So I will be taking you through that step-by-step approach, how you will be organizing that data that is coming to you, what kind of an IIoT platform will help you in implementing that. And after that, you receive that data, what you will do with that data. So certainly visualization is the quick outcome that you can see that, or low-hanging fruit that you can immediately implement the dashboard through which you will be able to see at least the activities or getting a first insight what is happening inside it. And post that how we can use it for the various analysis. So that is what I will be briefing about this data organization analysis in this session. Then we'll have a quick review of the things that you will be implementing and thinking about the project idea. So, and certainly some of the homework part that we'll review. So kind of a mid-course review to understand whatever we are explaining, whether you will be absorbing that or whether you are facing any difficulty. So we'll be aligning more resources and helping you in that. Then we'll have a session on additive manufacturing planned on that day. That is what has been planned for the 1st February. Then post that, I will be sharing with you the kind of robotics application in manufacturing. So we have already done some of the quite a good robotics project in FSM at IIT Delhi. So we'll be sharing that experience with you. Probably from that learning, you can find out similar applications coming out at your place and in your mind that you can think about those applications. Then we will be taking a session with an invited speaker on the condition monitoring for predictive maintenance. So that is another session that we'll have for the 1st February. Post that, I will be discussing, because once we start thinking about the data, then the next technology which is going to reside on this data itself is the machine learning. So we'll be, I will be taking that session on machine learning for smart manufacturing. So what are the technologies available? Which are the possible application of the machine learning? And certainly my effort is always in giving you the confidence that these technologies are easy to learn and implement. It's a very important part, because most of us are coming from a different background of mechanical engineering. We are dealing with the machines and the equipments. Whenever it comes to understand the technologies related to the electronics or mostly on the computing science, we are keeping a distance from them. So my effort throughout the course will be to at least give you some kinds of a hands-on experience or the technologies or the possible methods by which you can easily implement, at least take a first step. Even if you are not implementing, most important part, if you are guiding a project, then you should be understanding nuts and bolts, then how these things can be implemented. So that is the idea of having this course. Certainly for all these topics, the time frame what we are having may not be good enough to at least go and learn everything and implement, but at least you will be getting in a spark and understanding, yeah, this is the right way of implementing this particular technology, and this is the probable solutions, or this is the probable area where you can implement these technologies. So that is the effort that we will be making through these individual topics over here. So in that continuity, we will be having in a session on the cyber security, because we are all talking about the data exchange from one place to another place, and then it will be captured from the factory floor and taken to the IT sectors or IT services. How we will be securing this data when it is moving around. So that is how the approach to the cyber security will be given in this session. Another important technology, which is certainly again futuristic, it's a digital twin. It's a kind of an agglomeration or combination of the multiple technologies we will be talking about, whether it's in a sensing, IoT, machine learning, or the physical science, actually combining everything together, how the concept of the digital twin will be built up, and then how it is going to help us in the manufacturing. So I will be taking that session on the digital twin in manufacturing. And post that, we will be having the last day. So whatever the course project you will be taking up, we will be having a presentation, because that is the day when I will be going to listen from all of you. So your project ideas, the presentations you will be making during this session. And lastly, because we will be moving towards the concept of the industry 5.0, so we will be having a quick briefing about the concepts of the industry 5.0 in that session. And finally, the closure by the course director. So that is what we have planned, and we try to touch upon almost all the technologies which are relevant for the implementation of industry 4.0 and smart manufacturing. So that is how the whole course has been planned for the 6 days. Earlier, we used to have this course for 5 days. We have increased 1 day to cover more on the digital twin and machine learning and cybersecurity this time. So that is how this 6 days are being planned. Now, apart from these live sessions, as I was mentioning, we will also be sharing with you additional resources in the form of the video lectures that will be available. We are suggesting some of the reference reading, which will be helpful related to these technologies, which we will be discussing. Because as I was mentioning that we may not be having enough time to interact and understand the whole concept of a particular technology is 1.5 hours or so. So these additional resources will be complementing that whatever we will be discussing and sharing during the live sessions. then certainly there are certain activities to be done, whether it's an experiment or maybe some kind of an implementation or experience of some AR. So we will be taking up those activities as well. So these are also listed in the on the website which will be dedicated for this course. And there is an evaluation component associated. For each day, we will be going through some kind of a learning, and we will be having a thorough evaluation going on along with it. So there are various quizzes, and some of you have already started and experimented with the basic quiz that I have already floated yesterday. Those who are able to log in into the system, they are already performing that pre-course quiz that has been given to you. And there are few surveys that we look forward. So one survey you have already attempted. So this kind of activities and the evaluations are also part of this. So we have all these components delivered to you through this e-learning platform that I will be briefing about. This is a very important part of any technology implementation. When we talk about the learning, we start basically from the awareness.
IIT Delhi का है प्रोफेसर इंडस्ट्री 4.0 के ऊपर.
ओके, अच्छा आज बात की हमने उससे.
So please keep yourself in mute if you are doing something else during the course. It's not encouraged. Lata ji, if you are there, please mute the participant.
आपको quote IBM के साइड से दे या आपको इम्प्लीमेंटर के साइड से मतलब कोड चाहिए. हम बोले यार अगर IBM कोड दे देगा तो ज्यादा अच्छा है.
यार IBM थोड़ी देता है यार, हमें एस्टिमेट के लिए चाहिए. वो कहाँ?
Bharat Singh ji, we are hearing you what you are communicating. So it's not good idea to talk in the course.
Sorry boss.
So all the participants, please keep yourself mute. If you have something to speak, unmute and then talk about the course we are going through. So what I was just mentioning that the success mantra for Industry 4.0 smart manufacturing implementation is that we have to start with the awareness part. That is what we are trying to build up and then gain appropriate knowledge in this direction. Then we have to get some kind of an expertise in implementation. And that is what it's very important. Unless you implement, unless you do that exercise, the whole learning will not help. Because it's all about manufacturing, and unless you implement these technologies in manufacturing, you will not see the results coming out. So that is what we always take you through these steps whenever we talk about these technologies. So we look forward that all of you will gain some understanding and knowledge from these sessions, and you will be looking forward for the implementations. And that is where the component of the project is coming. At least you start conceiving the ideas for the implementation of these technologies. So today's session, we are a little late on that, but we'll try to cover up some of these concepts. So first session is on the Industry 4.0 smart manufacturing technologies, and then convergence of the automation and IoT. I have already briefed, and then we have an invited session. And lastly, we'll talk about the course project formulation. These are the additional tasks. I will keep on reminding you and then giving you reminders for completing them, because every day we have an associated quizzes. Basically, once you go through the learning on that particular day, you have to attempt that. We'll define a time frame for implementing and attempting those quizzes. And then we will be having some homework to be done. So these are the two tasks that I will be briefing as I go along in my technical presentations, redefining the Industry 4.0 in Indian scenario. Because when we talk about the Industry 4.0 terminology itself is what we all understand is coming from the Europe, because they have classified the whole industrial revolution into 4 different revolutions, and then they are talking about certain technologies in Industry 4.0. But when it comes to the implementation in Indian manufacturing scenario, certainly we have to look from our perspective. What are the kind of manufacturing challenges we are facing, and what kind of solutions are coming out after implementing these technologies? So that is what we always emphasize, that we have to redefine the Industry 4.0, at least in our own perspective. So we will take up through that exercise. Then we have to define this. Samarth Udyog is something which has been already mentioned and then we are talking about smart manufacturing. So if you see that if we combine together, it's a smart Udyog or Samarth Udyog. We have to just see the capabilities and the smartness together. So we have to define our vision statement actually. What is our vision for the implementation of this mission of the government of India, who is looking forward that we have to make our industry capable actually. So we have to put our vision with respect to our own organization and wherever we are implementing that. Then there's a short IoT survey. I will request you to participate after we finished all these sessions today. So we'll open that survey part so that you can give your inputs, and certainly based on that outcome, we will continue the discussion tomorrow. So these are the exciting tasks for today. Post course, you have to spend some time in at least completing those tasks. So Amit has already briefed about this foundation, which is an IITD-AIA Foundation for Smart Manufacturing. We call it a common engineering and learning center or learning facility. And it has been specially established to understand or demystifying the technologies related to the smart manufacturing or industry 4.0. So if you see the structure, the way we are working in this foundation is little different than a normal academic structure. When we are working on a different industrial projects in IIT Delhi, we are mostly dealing with one organization, working for a project with them. You might have also worked with the different organizations or maybe institutions. Here, what we have planned that we try to bring out the state-of-art learning available across the world actually. That is how the role played by the industry partners with us. So we have these industry partners working with us in this foundation. So when we created this FSM as an entity, that is what we are trying to bring out the learning available elsewhere in the world, and we have to work together in this academic infrastructure. So we try to bring out the various specializations which are very important for this implementation and understanding of industry 4.0, whether it's in a industrial automation, additive manufacturing, embedded systems, control automation, because as you see that this is more interdisciplinary subject. When we start with the automation and mechatronics itself, it will be more interdisciplinary. But when we try to bring out the computing systems and the knowledge based on the data science, then it is even making more interdisciplinary, whether we'll be talking about the cyber physical systems. So all kind of a specializations that are available at IIT Delhi, we try to put them together at FSM. At the same time, we'll also be working very closely with these industries and then MNCs, which are developing these solutions and what are the technologies available with them. So together we have created this foundation so that we will nurture this understanding and the knowledge on the smart manufacturing. And we have spent last 3 years in at least building up that knowledge. And now it's a time that we will be sharing this knowledge with the participants from the industry. And we are conducting various training programs for the academics as well as the industry. So FSM, we have our own lab and facility where we keep on working, developing the technologies and trying it out actually. The good thing about this platform or this facility is that we will be doing hands-on and attempting some of the new concepts and trying it out on this machinery. So before we take it to the actual factory floor implementation, all kind of prototyping and testing can be developed can be done in this lab. And then once we are sure about this particular software hardware is going to work and help me in implementing and solving this problem, then we will be implementing on the actual shop floor. Quickly introducing the FSM team working with us right now. So we have directors representing industry as well as the IIT Delhi. So this entity FSM is basically co-owned along with the industry. So we have Mr. Ravi Agarwal, Mr. Anup Wadhwa and Dilip Sahani from industry. They are representing Automation Industry Association. And Dr. Anil Wali and myself, we are the representative from IIT Delhi in this foundation. Then we have a set of young engineers working with us day and night, experimenting with these technologies. So we have people in automation and IoT, Mr. Arun Kumar and Vishnu Kumar. We have Rajesh Bhatt working on the robotics and the implementation of the robotics projects. Vaibhav Anand working on the software development part, whether it's an AR implementation or the backend with the Python and then JavaScript integration. So he's developing those applications. And Naman Kapoor is looking after the administration at FSM. So I'm just introducing because during the course, we have to go through some kind of an hands-on experiments and the learning part. So these are the people who will be helping you in at least attempting that part. Then we have a lot of interns coming to FSM working on different technologies. So right now, Ronak, Atul, Omkar, Amit, they are all working as an intern with FSM. The course faculty that we brought in this course, whatever I have briefed about the 6-day structure. So we have people from various industries. They will be joining these courses and the respective lecture sessions. So we have Mr. Anup Wadhwa from Automation Industry Association, Mr. Kalyan Ram from Electrono Solutions, Mr. Sudhanshu from Pepperell and Fuchs, Pankaj from Rockwell Automation, Mr. Piyush from MathWorks, Tushar from PTC, Mr. Sarup Chand from Adroitech, Mr. Praveen from Deloitte. So we have brought these faculty members from the industry so that along with me, they will also be sharing their knowledge and learning what they have gained in the domain of smart manufacturing. So quick introduction about this common engineering facility, which I was talking about. So to start learning on these technologies, certainly we need to have a basic infrastructure. And that is what I was explaining, that with the help of industry consortium and along with the support from the Department of Heavy Industry, we created this basic infrastructure for learning. So rather than start learning directly onto the actual facility, we have created this cyber physical assembly line, which is an assembly line of an electromechanical component. So we have designed this assembly line. We have manufactured this assembly line at IIT Delhi. And the idea is that once you order any of the component online, actually. So this is an assembly line which is dealing with the automation systems as well as the robotic systems. And they are able to assemble the whole component, which is an electromechanical component. And some of you may be familiar with the pneumatic valve or hydraulic valves. So this line is capable of assembling such kind of components. So I can initiate the operation by going to my application, that is in a web application or the mobile application. And once you order your component, this line will start assembling. So each station has a role to play. It start assembling with the basic valve body and then spool insertion, finally placement of the electromechanical components. And I will take you to the live view of this facility also as we go along. So that is also in the agenda. And finally, this valve get assembled. And then we need to go for a functional testing. So this facility is also giving you a quick comparison about the conventional way of assembling in a system. But in these stations, we are continuously monitoring and capturing the data as the assembly process going on. And then we'll also be showing the capability of a robotic system in performing the similar assembly operations. So whatever these three stations are able to assemble, this multi-process robotic cell is also going to assemble the same component. But apart from that, it is also be able to do the functional testing of this developed component. So this assembled component is going through the functional testing in this, and finally packaging of this product. So starting from a web ordering to the final dispatch of the assembled product is all being demonstrated in this small assembly line. And as this assembly line is going on, there are various technologies are in operation. So the idea is that through this simple assembly line, we will be able to at least touch upon all the technologies, how they are going to help us in transforming the way the manufacturing operation takes place. So this is the facility. The another facility that we are working on. So this is the previous one is the state-of-art facility, which has been developed from the scratch. We have designed all the machines and systems, and we have created this basic cyber physical assembly line. The second facility we are right now working and implementing is on a cyber physical factory concept. And that is basically a mix of a new and old equipment. So idea is that most of the industries we are talking about and most of the Indian industries, we always come across this scenario that you have some old machines which may not even have a sensors and controllers. And then some of them are the CNC machines with the PLCs into that, and some of the advanced new systems like robotic systems. So we'll try to bring out all these facilities on one platform. And that is what we are trying to transform our central workshop in a cyber physical factory, to build up everything from the scratch with the connectivity part, upgrading the basic legacy machines into smart machines, and then try to develop the whole smart factory concept. So this is in a micro production system connected with the automated material handling robots over here that you can see in between. It's in a mobile autonomous robot with a collaborative robot on top of that, doing all kind of material handling within the shops. So this is the one facility we are developing along with the previous cyber physical assembly line. That this is more related to the manufacturing, so all machining, forming, welding, these operations are going on in this facility. We would like to demonstrate that how a track and trace will work in that case. So starting from a basic raw material tracing, the material movement to the different machines will happen. The quality inspection can be implemented, how the inline quality inspection can be implemented. finally the finished part can be dispatched to the customer. So this cyber physical factory is going to demonstrate all these functionalities. Another facility that we have created is on the training part, because that's very important. Whatever basic infrastructure what we have created is on the machine side, but at the same time we'll also like to transfer the learning to the learners, basically, whether it's a student or whether the people from the industry. So these smart manufacturing training system we have created in our lab, and we'll try to give you some kinds of an hands-on learning on this system as well during the course. Idea is that we should have a remote accessible training system, because these days we may not want everyone to come to the lab and learn it. So we will be providing these training systems will be accessible remotely, and they can learn these technologies which we are talking about. So we have this smart manufacturing training kit connected with an electromechanical hardware also, which is a representation of a machine having 4 different stations with the sensors, RFID, because I was hearing that you are implementing RFID projects. But at least those who are starting this initiative activities, starting from a basic data capture to the taking it to the IoT platform and developing the applications for the customer, means how everything will work in this scenario. So that is the idea of creating this smart manufacturing training system. So these are the trainers that has been created on a state-of-art industrial automation hardware, whether it's an IoT implementation on these kits or the smart managed switch for the network security.
Hello.
I think there is a glitch in Dr. Jha's connection, so we'll just wait for him to join us back. Yeah, he's reconnecting.
Yeah, I think something wrong with the network. Immediately it gets switched off. So I just come back again. Yeah. Yeah, hope my slides are visible now.
Yes, they are visible.
Okay. So I was just mentioning about the smart AR trainers. So many times we may not be able to make the physical hardware available for the training. So we have created this application, which I will also allow all of you to at least do a quick experiment on that. This is available on Google Play Store, through which you will be able to visualize the same training environment, which I was just explaining through the augmented reality. So this I will explain when we go into the augmented reality session, but I will request at least you can download this application on your Android mobile phones, and you can at least do some kind of an experiment. So I will be uploading the instructions on the FSM skills, how you can use this application. So that will be helpful and give you at least a quick glance on the technology, how that will be helping in learning and the training. And this is the website I was talking about, where we will be trying to bring out the blended learning. So certainly these kind of live sessions I will be having and we will be having for you. And then it is supported by the relevant e-learning component over here. So there's an e-learning. Then we'll be also organizing some of the live demonstrations for you on our infrastructure, conducting some of the hands-on lab and course project and quizzes. Basically, all that will be conducted on this e-learning platform. And that is what I would like to make sure that all of you will be in a position to log in into this system. We have already shared your login credentials so that you may be able to get an access to it. So please log in into this website and try to start following up with us, as we will be sharing with you what you are supposed to do, what all activities you can go through. So we have already put through a very structured course plan, what all activities you have to follow up, or what all reading material you have to go through. So this website will be a kind of a companion as we go along during the course. Fine. So after this briefing, let me start this technical talk on this Industry 4 and Smart Manufacturing Technologies overview. And as I was mentioning, that this is one of the initiatives taken by the government of India, and we call this mission as a Samarth Udyog. So all these initiative, all these activities, what we are doing are in the name of the Samarth Udyog. As you can see that the various countries are having their different name for this initiative. So Industry 4.0 certainly started from the Germany. We all is following that same terminology, but for India, we will be talking more about the Samarth Udyog. Let me quickly give you a glimpse of the transformation of the industrial revolution. Some of you might have already aware of this. So I'm giving you a quick glimpse of the kind of development happened with the example of a lathe machine, because we all are mechanical engineers. Most of us are mechanical engineers. Even not mechanical engineers, I'm sure that all of you might have gone through the operations on the lathe machine in the first year of your engineering itself. So this lathe machine, as we try to understand how the concept of the machine build up. So we have understanding of the metal cutting mechanics, because someone has to come out with how the metal can be given a different shape. And then if you want to give them a axisymmetric shapes, then the metal cutting mechanics should be understood. So there should be a cutting tool with certain angles. And then if we engage with the workpiece material, we will be able to remove the material in a particular shape. With that understanding, people have come out with the concept of the lathe machine. So they understand what are the various relative motions are required in this lathe machine. So the whole understanding of the mechanical system should be there, the machine tool to be understood, and then how you will be powering these machine tools. So this lathe machine started with this itself. So you will be having the power source as a steam engine during the first industrial revolution itself. So that the main source of power for this machine will be coming from a steam engine. But at the same time, you will be implementing the metal cutting mechanics with the different relative motions that you will be giving to the tool and the workpiece. So that is how we can understand how the technologies start developing when we talk about the Industry 1.0. When you know the basic mechanical systems, and you will be trying to build the basic machines that are driven by the steam engine. So that is how the first industrial revolution starts. Then we talk about the lathe machine. Again, same mechanics is going to be implemented. And then that's the way that metal has to be removed from the workpiece. And apart from the mechanical systems, you need to understand the electrical systems as well, because now your machines are no more driven by the steam engine. They are driven by the induction motors. So the people with the electrical system understanding, they put this motor together with this machine. So the rest of the operations remains same. Only the motive power, the drive power will be coming from the AC induction motor. And the motions, the mechanically coordinated motion, whether a depth of cut or the speed, feed, all are being given manually in these machines. So that is how the understanding of the basic mechanical engineering is still important, and you will be able to produce these kind of parts. Then if you go along, the transformation happens that whatever motions you will be giving to this machine, what I was just mentioning in the previous slide, they all are being controlled by the servo motors here in this case. So that's how the concept of the computer numerical control machines has been developed. And that we all are familiar with, because all of you might have seen the CNC machines. As a mechanical engineer, we understand the CNC machine. As an electrical engineer, you understand the CNC machine. We also understand what kind of programs are being running into this machine controller. So if you see the way the technology has been transformed, that is starting from a basic metal cutting mechanics, how the system is being driven by the electrical motor. So initially only the spindle part is being taken care of by the electrical motor. But later we realize that whatever the mechanical motions the operator is giving to the part, in terms of the relative motion between the tool and workpiece, again, if that is being coordinated and being given in a proper way, you will be able to maintain a better quality of the product, and you will be able to maintain a better dimensional accuracy. So this kind of system has been developed with lot of intervention of the electronics into this and lot of intervention of the computing environment into this. So if you see here, you need to have a mechanical system. You can't go away from that because that is the actual foundation of your machine. Then we need to bring out the electrical systems to drive the whole machine tool. So you will be having a servo motors, drives, running the spindle, the various axes of motion is to be implemented. And finally, you will also be bringing out the computing system, because now I would like to give the instruction to this machine in the form of an alphanumeric codes actually. And that is what the part program we have to put into the machine. Then machine has to understand that part program and generate a suitable motion to cut the part. So if you see that journey that has moved from the basic machine to this CNC machine, this is all has been done as a part of the industry 3.0. So in industry 3.0 witness all sort of automation that is being implemented in the form of these CNC machines, robotics and all. Now, when it comes to the industry 4.0, what additional thing we would like to do here? So I'm just giving you an example of a smart lathe machine. So same machine tool, nothing is going to change as much in terms of the basic metal cutting mechanics, nothing going to change. Only thing what we are looking forward now, so beyond the conventional automation, now we would like to build more services on top of that. So what we would like to have, so automation merely not give me the product quality. What we are looking at even on the legacy machines or the conventional machines, how we will be able to ensure that the product quality is maintained irrespective of the operator operating it. So we need to build a services which will be helping in getting the right product quality from this machine. We'll also be looking forward that the health of the machine is being monitored here. So we would like to monitor the continuous health of the machine, the precision of the machine. When we say health, is certainly the precision of the various components or the sub-components which are used in the machine. And we also look forward, because when we talk about the conventional lathe machines, we would like to guide an operator in some way that we will be able to maintain the product quality we are talking about. To achieve these basic functionality on a conventional machines, now we need to think about the kind of integration we all are doing, or we may be doing it. So I have heard about that you started some kind of an industry 4.0 projects. They may be looking similar to this. So I'm just giving you a very crude example or the raw example of a conventional legacy machine. But if you have a CNC machine, you have a better prospects of integrating that machine. But let's take a very raw case over here. So my intent is that I should capture some of the important parameters from this machine. So I will be thinking about what are the critical parameters for this machine. So we understand that the speed, feed, depth of cut are very critical for a lathe machine. And that is basically directly translating into the product quality. So we need to think about capturing these parameters from these machines. Then certainly when we talk about the vibration into the system, so we are interested in capturing some of the vibration signal from this machine. Then power consumption by this machine is also a good indicator. So sometimes when the parts are wear and tear, there's a large amount of energy consumption, or there's a change in the trend of the energy consumption by the same machine for the same part. It's also a signature that we need to capture. So energy monitoring is an important part of this. Certainly some kind of controls we would like to implement. So coolant control, power on and off of the machine to be monitored. There are certain safety measures can be implemented on this machine, because we are talking about now industry 5.0, which is also to be making the whole system safe for the human to operate and work in this environment. So safety is one. So that kind of features can also be implemented on this machine. The RFID based access, because we want to record who is operating the machine, which part is being produced by that person. So there's some kind of a traceability of the components, as well as the traceability of the operator who is going to who has used this machine. So we have to provide some kind of an access system here. So RFID based access will also be a part of this, and certainly monitoring of the bearing temperature. So we understand that there are certain parameters of all equipment or the machine tools which need to be monitored to deliver all these services which I was talking about at the bottom here. So the conventional machines don't have anything basically to give you these inputs. So what we have to do, we have to start thinking about the various sensors to be integrated into this machine. So we have to put an encoder over here to capture the RPM, or we have to place a vibration temperature sensor on this spindle to monitor the vibration. And then you have to place additional sensor onto this speed, feed, and depth capture actually. So I will take up this machine example in detail later on, but just to give a quick glance of what kind of information to be captured from a machine, and how we will be taking this information into an IoT platform to make use of it. So we will be then placing a controller to capture all this data here and connecting to the gateway so that we can take out the data from this local hardware to the server, basically, because that's a location where we will be able to process that data. So when we talk about the data capturing and visualization and analysis, we need to take that data to a platform. So we will be taking data through IoT gateway to the IoT platform, and then we will be implementing all sorts of services that we are talking about. Now we are also keen to give a feedback to the operator. So this is fine that you are extracting the data from the machine, try to visualize and analyze that data, and at the same time, we would like to give it feedback to the operator. So some kind of an operator guidance should also be available. So we need to have some kind of a visual system available on the machine. So for this lathe machine, we have implemented a small display-based system so that it will give an operator that indicator that he has to change the speed, feed, depth of cut in a particular direction. Either he has to increase or he has to decrease, so that we will be able to maintain the right product quality. So this kind of an interaction with a physical infrastructure is basically creating a concept of the cyber physical integration, because now you have a physical machine, physical equipment that is available. You will be establishing a cyber connect with this machine, that you will be taking the data from this machine, analyzing that data and processing that data into the cyberspace, and then sending the information back to the machine tool. So if it would have been a CNC machine tool, I will be giving direct instruction to the PLC so that it will be able to adjust those parameters with the help of the servo motors which are there on the machine. But as this machine is operated by an operator, so I would like to give a visual indication to the operator. So that is the way these indicators are being designed in this case. So we need to cover up both the type of machine which are already having a capability of a controller inside them, and then they will be able to control the machine directly, like a CNC machine or the robots. Or if it is being a conventional machine, we need to think about the options in which we will give a feedback to the operator who is running this machine. So we are looking forward for this kind of an implementation when we are talking about the Industry 4.0. That is the cyber physical connect is a very important part of this implementation. So the 4 design principle and goals for Industry 4.0, what we are looking forward is the interconnection, because that is what I was just explaining, the connectivity between the machines, device, sensors, even people, basically, how they will be able to communicate among themselves. So that is the first design principle, that whenever we are trying to implement, or whenever we are thinking about the implementation of Industry 4.0, the connectivity is an important pillar over here. So those who have already started this journey, they may understand this. First thing is to extract the data from the machine and then take it somewhere else. And then that somewhere else could be a server, or it could be the another machine or the system which will be making use of that information, or it could be in a mobile application where we will be taking this data. So this interconnectivity between the machines and the sensors and the people is very important element of this. Now, once you establish a connectivity part, then it's a second design principle is the information transparency, because that's a very important pillar of Industry 4.0. As we go along and implement the smart manufacturing, information transparency will be there. So it provides the operator or the decision makers this transparency. They will know that information. All decisions are coming out with the knowledge or the information that they are looking at. So I should say, the informed decisions coming out from the actual data that is coming out once we implement the information transparency. The another design principle for Industry 4.0 is the technical assistance. We are looking forward to empower people, basically, with the help of the technology. So when we talk about the Industry 4, it doesn't only talk about the machines and the connected systems. We are also talking about the assistance to the people, actually. So the technological facility of the system to assist a human in the decision making. So decision making and the problem solving. So kind of a solutions where you are talking about with the help of a machine learning and deep learning implementation, the kind of inferences can be made based on the data. On one side is assisting and helping in the decision making. At the same time, if you would like to assist someone to solve the problem or in the field also, so the technological assistance in the form of the technologies like augmented reality will be helping people and they are guiding people to do the problem solving. So this is another important pillar for Industry 4.0. And lastly, we are talking about the decentralized decisions. Rather than everything coming to one central system and the decision being communicated to the machines, we want that the decision should be taken by individual decentralized components, or I should say the different hardware near the machines itself or the machine controller themselves. So the distribution of the decision making. So decision making should happen at the machine level itself. So some sort of decision making with the help of the cyber physical connect. I'm not saying that the complete decision making happens with the machine controller only. Certainly this decision is coming out in processing with the server who is doing this information processing and communicating back to the machine. So we look forward for this kind of a decentralized decision making. Some of them are being processed at the machine edge, some of them are processed in the cloud and then communicated back to the machines, so that we would be moving towards more and more autonomous systems. So this decision making should be more autonomously. So this is what the basic design principle, and all technologies that we will be talking about, they will be at least trying to implement some of these design goals. Now let me take you to this important slide of manufacturing challenges, because whenever we talk about Industry 4.0 or smart manufacturing, we always think that we have a lot of manufacturing challenges already existing in the facility which you are dealing with. Now, when we talk about Industry 4.0, we always see that it's a next generation of the technologies that are going to be implemented for a futuristic manufacturing setup. What we will do with the existing manufacturing challenges. So our manufacturing challenges are always in the form of either a higher rejections, very less insight available on what is going on in the factory. So lack of operations insight. That is the reason that you are trying to connect the machines, connect the assets, and try to build more dashboards basically, because that bring out the insight part. So wherever it is not available, you are always in the blank, that you don't know what is going on. Where is the fault? Where is the problem area in either the manufacturing or maintenance? So lack of operations insight is a very big driver for this. And most of the time we see that most of the manufacturing facilities and setups are experiencing these issues. Then suboptimal process control. We are running the processes, manufacturing operations, but they are not running at the optimal conditions. So first time, or sometimes we are able to tune these operations, but then we are not continuously monitoring that whether it is running in optimal conditions or not. So suboptimal process control is the another challenge that we always face. Long setup and the production time is another challenge. Unprecedented downtime is very critical whenever you see that the very important asset failed all of a sudden. And that's a very important part of your manufacturing setup. So this unprecedented downtime will be going to impact the whole business scenario. So this is a very critical, unless you know something in advance and you will be in a better prepared state to deal with this kind of a downtime. It's very challenging whenever it happens in the manufacturing setup. We are always thinking about the utilization of the equipment and the performance of the equipment. So the OE is very important parameter to capture so overall equipment effectiveness. So low OE is another challenge with the manufacturing setup. We are not able to produce what we are supposed to produce at the right quality and the right number, as well as the asset is not properly utilized. So that OE is also an important measure which we need to monitor, and then we need to improve that component. Delayed decision making is also impacting the whole setup. And when we are talking about the smart manufacturing, decision making is very important there. And whatever technologies are coming up, they are accelerating the decision making process. How we can accelerate that decision making so that the important production time should not be lost in that case. So this is another challenge. Then in process variations are happening, whether you are able to capture them in time or not. The kind of rework need to be done to meet the quality requirements. Then dealing with the manpower, which is unskilled or the semi-skilled, how the technology will help these kind of people to perform their task or the job responsibilities better. Another challenge, as I was telling, that people start implementing the Industry 4.0 and they know that the data is being captured, but this data is not captured in a proper way, or this data is scattered throughout the plant. Actually, it's not being brought in a single unified system. So this is scattered and unstructured information throughout the plant is another challenge. Unless you consolidate them and put together, it is not going to help you much. And the machine maintenance part. So these are the a lot of challenges we all understand, and maybe the list may be growing, and then you may be having some more challenges that you can add to this slide. But the important thing we need to communicate with this slide is that there are already existing lot of manufacturing challenges. And when we are learning the new technologies, our emphasis and focus will be to use these technologies to solve these existing challenges. So in any form, Industry 4.0 doesn't say that you have to do this only, then you say that you are doing the Industry 4.0. Any technology which we are talking as a part of the Industry 4.0 smart manufacturing has to solve your existing challenges, and some of these manufacturing challenges are being listed in this slide. So this is the slide we need to understand in a better way, that on one side, we all are familiar with our own challenges. So maybe after this understanding and discussion, you may write down your own challenges. That's a very important part. I have already written based on my interaction with the industry and understanding. These are the some of the challenges. You may increase that list further. And other side, in these 6 days, you may go come across and understanding the various technologies that we will be sharing with you. So there are technologies basically like the real-time information, the data visualization, data analysis, remote maintenance, smart machine interfaces, augmented reality, AI machine. So these are all technology baskets or technology components which are relevant and important for the smart manufacturing understanding. These are the two different scenarios. On one side, you have your existing factory challenges or the setup challenges. And other side, we are trying to learn more and more advanced technologies. Now, unless we marry them or match them, now which challenge is getting solved by which technology component? Unless we come out with that visualization and understanding, this learning will not be helping us. It is not going to be implemented. So it's a very important exercise for all those who are having a field experience and learning these new technologies. They should understand that this particular technology is going to help me in solving this particular challenge. So please be ready to prepare this kind of a list for you. And then as you go along with the various technologies, which I have listed on the right-hand side, as we will be discussing more in more detail about these technologies, you should start thinking and then matching that. And that is something is coming out as a project. So whenever you start thinking about implementation of these technologies to take out some of these challenges from your existing setup, then you are implementing Industry 4.0. Let me give a quick glance of a digital enterprise, because that's a very important thing we are moving towards actually. So today we are trying to implement digitalization. We try to do everything digitally. So when we talk about the digital enterprise as such, so what exactly we are doing in the enterprise, we need to understand that. So when we talk about manufacturing, certainly we are doing design, we are doing manufacturing, we are manufacturing some products basically. And to manufacture the products, we need to bring out multiple components, sub-component, raw material into this. So supply network is very important, and the distribution of the final finished products. So these are the key important pillar of all manufacturing setup. And then you see that there's a word written digital in front of all these terms. So digital design, digital manufacturing, digital product, and certainly the digital supply chain network. And everything is being connected together with this information exchange between all the digital environment in the enterprise. And that we call as a digital thread. It means that all the activities in the plant and the enterprise are being now shared digitally. And then this highway of communication, which is sharing this information digitally, we call it a digital thread. So how you will establish that digital thread, how you build up that digital thread is an important part of this. And we are certainly looking forward for migration to our existing manufacturing setup towards the digital enterprises. So this slide is just giving you a quick glimpse of that, what exactly digital enterprise means and what are the digital design. So I will just zooming into this little bit to understand what exactly I'm talking about. When we talk about the digital enterprise, we'll be talking about the digital organization, digital enterprise content management, enterprise risk management, the research part, Then as we go deeper into the manufacturing, we'll see that, so when we are saying digital design, so we all are familiar with, certainly we are doing most of the design activities digitally today. So we have to use CAD packages. We have to use the analysis packages. We have to design the product. We have to evaluate the product reliability. So all sort of the digital tools that are going to help me in performing these activities are making a digital design. Then we will be talking about the digital manufacturing and processing basically. So when we are talking about the digital manufacturing, now we need to monitor the manufacturing and processing systems. We need to control them digitally. And certainly we will also be performing some sort of a simulation and before we actually take it up to the manufacturing. So if we do all these activity digitally, then we call it digital manufacturing and processing. Same way we are looking forward for the products. Now no more products are being in a way that they are not sharing something, because when we are talking about the digital economy, digital enterprises, we are looking forward these products are to be sharing this information back to the system. So we are looking forward for more digital product which will be sharing information about their utilization and then the current state. So that is how the digital products are coming up. And finally, we are having a supply chain and connecting everything together, whether it's an automated material handling or the planning of the supply chain. Once you connect everything them together, the digital thread part is coming here. So digital thread is how you are exchanging the data between these digital entities within the enterprise. So you need to think about the security, you need to think about the data science and management of this data, the data pathways, how the data is flowing, and then certainly the applications of the AI. So this is the way, and I'm again going to zoom little bit, not just to read out everything, but if you go into the detail, you will find the further nuts and bolts of each and everything which I was just mentioning about. So when it comes to the digital manufacturing, when we are talking about the monitoring, we are talking about the sensor, the connected equipment, the predictive maintenance, the asset performance monitoring, and the digital metrology, quality, and so on and so forth. So that is how, as we go on deep into the implementation of the digital enterprise, we have to understand all these building blocks and then try to start implementing in that direction. And digital enterprise or digitalization is again a very important driver for the implementation of the smart manufacturing. Now, when we talk about the technologies that are going to shape the future of manufacturing, this slide is very important because this is one of the study being conducted by the PwC. And the whole report is there in the e-learning section for you, because I just picked up the one slide from that report. But Digital Factories 2020, this is a report being published in year 2020 by PwC. What are the technologies which are going to shape the future of manufacturing? Some of these we are accepting today, some of them we are still thinking that they are futuristic. We may need to learn, but later on it may not be going to impact the activities right now. But they are going to impact your manufacturing setup. That is what this report says actually. And you see that they have just come out with the projections for the next 5 years. And we are not far away from those 5 years. Certainly some of things got impacted positively or negatively, we can say, with the COVID. People are more toward these technologies when they have seen the scenario of the COVID and the manufacturing in these days. So technologies like most of the digital twins, they are talking about the big data driven processes, predictive maintenance. So you can see that with the current usage to the futuristic implementation, most of them are leapfrogging from more than 38–40% from the current state of implementation. So this gives us at least a motivation to learn these technologies, because that is how we look forward that these are going to impact our manufacturing. And whenever we are talking about our comfort zone in manufacturing today may not be remaining a comfort zone unless we start thinking about an implementation of these technologies. So it's already 4:03. I will be interrupting for a break right now, and we will resume the session at 4:20 again. So please have a cup of tea, have a break, and then we'll continue after this. Thank you so much. And I will just take a pause over here and resume my slides again. Sorry. So thanks for starting the recording. Yeah, so we are talking about these technologies. We need to learn ourselves these technologies, and we need to also learn how to implement these technologies, because most of the time you will find that those who are developing these technologies, they may share a limited know-how with you, but it's very important to understand these technologies in depth to the extent that you will be in a position to implement yourself. So that is the idea behind this FSM, that we all are spending our time in understanding these technologies so that we can enable people from manufacturing to at least implement these technologies. So we are working on these technologies in FSM. Now let us come to this assignment, which will be due for submission by tomorrow. I will be enabling this assignment on the website. It's on redefine the industry 4.0. Now, when I was just mentioning about the industry 4.0 design goals, and I was also mentioning about the challenges in manufacturing. Now, from that perspective, how you see that industry 4.0 will be going to help you in whatever initiative, whatever activities you are doing. So this assignment is about identification of the key improvements in next 5 years. So whatever operations you are dealing with, whatever activities you are doing right now, can you just define, or can you just write down what industry 4.0 meant to you? Actually, what does it mean to you? So if I will be implementing industry 4.0 in my organization today, what kind of changes I can see in the next 5 years? So this assignment is just to list out those things. So once it is being enabled, please spend time and just mention these points. It may not be in too detail, at least you will be able to list them out. So the 4 key improvements in the next 5 years, you have to redefine the industry 4.0 for yourself. So that is the first assignment. The second assignment is about Samarth Udyog. Amit has already briefed about the Samarth Udyog initiative by Department of Heavy Industry, and we all are looking forward for the implementation of this vision of the Government of India. In terms of our own organization as a Samarth, basically, I'm sure that all of you may understand the meaning of the Samarth. And as I was giving the meaning of a smart, you may understand the smartness also. Or otherwise, what I will suggest you, please go to the FSM Skills website. There's a nice story about the Mr. Samrat. So if you just go through that, you will get to know about what Mr. Samrat used to do and what he's going to achieve once he's going to become Samarth. So idea is that we need to see our organization or our industry, our manufacturing setup to make them a Samarth. So you have to write down your vision statement. So vision, you all know that how to write a vision. It should not be too detailed, but it should be very brief, communicating that how you will bring more capabilities to your organization, whether it's in a machine, whether it's a people, whether it's a customer. All we have to put together in one statement. So this is again the second assignment that you have to write, so that we'll start building our vision and the clarity on, after learning the concept of industry 4.0 or smart manufacturing, what exactly we want to achieve. Unless we don't have a clarity, certainly then subject will be understood, but then nothing will come out on the ground. So that these are the 2 important assignments. Apart from the other, which I have opened yesterday, those who have not yet attempted, please attempt those assignments as well. And please log in. Those who have not logged into the website, please log in for sure today. If you face any challenge in login, please drop me a message on the WhatsApp group. We'll try to resolve and solve for you. But please do log in, because there are a lot of learning pending on that website itself, which you have to go through. So now I'll continue discussion on the smart manufacturing. Now we all are talking about the keyword manufacturing, but as you see, the whole perspective or whole scenario of implementation of smart manufacturing is not limited to manufacturing alone. Now, when we are implementing smart manufacturing, is certainly going to transform how the products are being designed, how the products are being manufactured, used, serviced. And that is what we are talking about, the digital thread. You will find the connectivity from throughout the digital organization. And even beyond that, when you are going to produce the digital products, they reach out to the customer, they will deliver the services, they will be informing back to the design people, these are the problems with the system, and then that's how they will keep on correcting that. So if you can look at the scenario that our design now start with the user specific data. Earlier, we were conceiving the product ourselves. I am sure that many of the products, maybe the Indian Railway also designing based on what the customer wants, the customer say, and the customer feedback that is coming to you. So in that case, I understand very well in terms of the IT services as well, when the application, the web services are going to perform differently and the feedback is coming to the backend system, we need to improve upon the whole system again, or maybe designing new kind of an applications. So in the same way, the manufacturing products also being started with the user specific data, because when we are talking about the customized manufacturing, we'll be talking about the start of the whole activity from the user specific data. So you have to get the consumer data captured from the products which we have already there in the market, or maybe the various sources where you will be getting the data as an input to start your design process. So with the user specific data, the whole design process will start. So product design using the customized data. You may explore, because this is what I'm just sharing within a broad concept of the industry 4.0. People are talking about the customized design, customized products, how it is relevant, in what scenario it is going to help you. That is what all coming as a redefinition of the industry 4.0. This may or may not be as it is applicable, but if it is applicable, it's nice. Otherwise, you can redefine how this whole activity can be redefined around the activities what you are doing right now. So we are talking about the capture of the user specific data. Then from that data, we would like to design a product which is again user specific, which is of a certain need and which is going to help the customer in some sense. So we are talking about the technologies which are helping us in designing the product which is user specific. Then we are talking about the digital manufacturing technologies, how you are going to manufacture this product. So all sort of the digital technologies involved, the data-driven operations, the manufacturing, the flexibility in the manufacturing, how the real-time changes can be implemented. So all these sort of technologies are playing a key role in implementation of the digital manufacturing. And post that, once the product is being delivered, actually, how the input from the remote product or the product being in use, actually, how the data from that product is going to help. So remote diagnosis and the reconfiguration can be possible on such kind of a connected products. So all sort of fault diagnosis, the kind of a maintenance that can be given to the product by the engineer or the service engineer or by the user sometimes, actually, and collecting the part failure data and improvement for the solution. So if you see that the whole, I should say the spectrum of the digital connect over here, starting from a user specific data, designing the product using the customer data, then manufacturing the product accordingly, and finally the product that is being delivered is continuously monitored and get connected. So we talk about the smart manufacturing in totality like this, and we will be embedding the intelligence at the different stages here. So that is what we try to manufacture with the intelligence. So this is what we understand the smart manufacturing concept. Let me take you through this quick snapshot captured from the Adidas. The 4 steps which I have just explained to you, they are being reflected in this video. Adidas are basically manufacturing the shoes. So this is all about how the shoes are being designed, actually. So the initial data is captured from the shoe itself. So it's an instrumented shoe, which is having some sensors there. And then based on the user that is going to use, the data is being captured. Using that data, now the product is being designed. So there's a unique member inside this shoe, which is taking care of the forces and torque. And that is specific, means how the strength of the whole shoe is being designed is based on the user specific data. And finally, this torsion bar, which is embedded into the product. So now this unique customized torsion bar is now embedded into the product. And then there is an advanced manufacturing processes so that you can make this product as quick as possible. So started from a basic input data, design of the whole shoes has been done based on the who is going to use it, for which sport he is going to use it. And this unique element of the product is being digitally designed so that it will meet the requirements of that application. And finally, suitable manufacturing processes that will enable it for being manufactured in this fashion. So idea is basically, though I have given an example of a shoe, but these 4 steps are equally applicable to any of the product we will be talking about in terms of the manufacturing. So then you can think about how this can be taken to some of your applications or some of the services that you would like to deliver. Now, when it comes to the smart manufacturing, we need to see the economic potential. What is the economic potential over here? So let me just quickly brief about that. As I was mentioning earlier also, it has to help the acceleration of the decision-making process and the adaptation. So there are two important advantages or the benefits that we can reap out of this smart manufacturing technologies. One is certainly the acceleration of the corporate decision-making process and adaptation. And second is the agility, how we can implement those real-time changes that is required actually. So if we have to manufacture something from the existing facility, how you can basically make your facility configure to produce something different which is required actually, or later on when you see the mix of a products, how they can be manufactured. So we will be focusing on these two things, the agility part as well as the acceleration of the decision-making process. So adaptation, let me explain how these technologies are going to play a role in the decision-making process at least. So I'm just taking you through two different scenarios, the current state of the adaptation or current state of the decision-making, how that will happen. So I'm just reflecting you with one facility. This is one of the manufacturing facility. And then there are certain equipments which are performing some operations and they get some event actually. So we call this an event that your panel temperature is now increasing. So this is one of the event. If the temperature of the panel increases at certain point of time, the first thing that who get to know about this, when this information is being available. So if you see here, when this event takes place at different point of time, you will get to know about this information. So when in the conventional setup, you will get to know about this information when someone visit the facility. When someone attend the operation or someone as a maintenance engineer will come and observe something that is not appropriate, and then he come to know about that the temperature of the panel is rising. So this is the point of time when the first insight about this anomaly is available, or first insight about this event is available. So that is what we call insight being available at 12:05. So when the event takes place at 11:15, you may have a less or more time for getting this insight. And this delay, what we call is an insight latency. When this insight is available, whether it's an insight about your own manufacturing operations or own manufacturing processes or any of these another services that you are giving, when this information is first time available to you. So that's a first insight you will get into the event, and that is what the insight latency. Now, after this insight, you will be communicating to someone to understand why this is happening. So there's an analysis process to start. So someone who is expert in doing the understanding or the calculation from its own experience, learning, he will be able to come out with certain analysis or understanding of this behavior, and the delay that takes place while the person analyze and come out with his own the report, we call it an analysis latency. So after the insight, to understand why this is happening, what are the cause of this, how many times it has happened in the past, all this information being processed by someone who knows the system well, and that is what we call an analysis latency. Whatever delay happens during this period, we call it an analysis latency. And after you analyze this data or whatever the behavior, you will be submitting this information to the decision maker actually. Again, the person who is analyzing is not going to take decisions. So then it comes that someone has to look into the details of the analysis and approve certain measures to be taken to curb this anomaly. So then there is a decision-making delay. So that if you see that after the analysis, there is a decision latency that will come into picture. And as you go along, you will see that there is a time lag that is being produced over here. So at 2:45, the decision is being approved now. Again, approval of decision doesn't mean that the decision being implemented actually. So there's another delay involved that finally someone has to go from the maintenance to implement those decisions. So then in that sense, if you see here, at 3:15, we found that someone will go make those changes, replace those components, whatever to be done to bring out the temperature within the limits. So this time that has been spent after the decision being approved till the decision takes place and the measures being effective now, we call it an action latency. So in the whole process, if you see that the moment that the event happened in the plant or the facility or in the manufacturing setup, by the time the final the measures took effect, actually, when the measures being implemented, you already lost some time. So in this hypothetical scenario, which I have explained you have already lost more than 4+ hours. Again, I'm just considering one of the situations. Sometimes it may be a complete shift. Sometimes it may be a whole day. Even the event happened, you don't know about that actually. So that is what you can see, that you have lost an important production time. So production lost and each minute count over here. So you already lost 4+ hours in this case. This is a conventional adaptation process or the decision-making process, how it works basically. Now let's look forward for a scenario which we are talking about now. So in that case, if you see here, the same event took place at 11:15 a.m. Now we already have a system in place actually. So we have already implemented the IoT. We are talking about that you are starting implementing of IoT, but for what actually? Because the moment this event happens, immediately you get to know about the alert. So you get through either the dashboard alerts, or we'll be getting a message on the mobile phone, or something is available to understand there's something wrong with the panel. And you see that immediately the insight will be available. So you cut down this latency, which is the insight latency, to the great extent if you build your real-time capability in the system. And this real-time capability can be built with the help of the various technologies. And that's what we are discussing during this course also. So once you have a real-time capability in your organization, it means that you are able to cut down the insight latency to a great extent, because the moment the event takes place, you will get to know about that event within the shortest span of time. Then post that, once that event insight is not good enough, we don't still want the people to just try to start understanding why this has happened. Now you have enough data available, which will help you in completing the first-hand analysis of this. So whenever such anomaly happens, immediately your system will analyze this data, and you will use a lot of technologies available to bring out the relevant information, that what is the relevant cause, what was the cause for such event in the past, why this has happened, what is the frequency of this occurrence of this particular event. So initial analysis can be done very fast with the help of implementation of these technologies. So you will finish the analysis much faster with the data analytics and the ML technologies, and you will be able to reduce the analysis latency time as well. Post that, what we want, we still be in a phase that we would like someone to approve the decision, but then you will be building up the decision support system, so that you will be presenting the information, or your system will be presenting the information in such a way that decision making can be accelerated. Sometimes we are talking about the prescriptive analytics actually. So it will be also prescribing that what should be the probable actions that you can take. So with this kind of data information being given in a right visualization form, decision approval will be faster actually, and you will be able to cut down the decision latency to a great extent. So if you can come out with a good visualization and decision support system, decision making will be faster for the human being as well. So though we are dependent on someone to take a decision, but then this is accelerated to a great extent with the help of the technology. So once we implement these technologies, we'll be able to cut down the decision latency. And post the approval of this decision, that the measure that, yeah, we want to adjust these parameters. Again, your system should be adept enough to make those changes themselves. So that is what we are talking about, the last stage of the implementation of the measures actually. So in that case, if you have a capability of the cyber physical integration in place, that your systems are connected with this decision making system, the moment you select an option that this particular measures to be implemented, and your system will reconfigure, readjust those parameters and brought down those, unless there's a physical replacement requires. So that is the way you can see that the whole the same sequence of the event and the decision making, once you implement the right technologies in place, you will be able to cut down a lot of latency over here. And once you are able to reduce the latency, certainly you are going to take more advantage of your the organization or the facility. And in this another next scenario which I have explained, you spend 11 minutes in doing that, and out of that 11 minutes we still kept that 7 minutes are based on the decision approval part, which is human dependent in that case. So later on, when we are talking about the decentralized decision making and these decisions should happen autonomously, then we will be even further cut down this time. So when you see here, we are able to reduce or save a lot of production time over here. And that's the advantage of implementing these technologies. So this is just a quick example of an acceleration of the decision making by influence or by integration of the various technologies, from starting from a real-time capable building to the final cyber physical integration. So now you understand the pillar of the technologies, where exactly they are going to play the role, and how they will be helping in reducing the lost time, whether it's in a breakdown maintenance time or it's in a production loss because of something not being communicated in time and then act upon. So this is the something we are looking forward as a bigger advantage coming out of this implementation. So when we see the important characteristics of the smart manufacturing, we all understand that we are talking about that we are implementing Industry 4.0. We are all talking about the implementation of smart manufacturing, but we need to understand what are the key characteristics of the Industry 4.0. So when I talk about these key characteristics, it will help me at least understanding where we are and what part we have already implemented and what is left out to implement further. So if you see that, though the design goals has already been explained to you, but when we talk about the characteristic of the smart manufacturing, the connected assets are one thing, the optimized. So these are the characteristics I will be explaining further. Transparency, we have seen that, the proactive measures, and finally the agility part. So if you start thinking in this direction, start taking steps in implementing each of these characteristics, then you will be moving towards the implementation of the smart manufacturing. So when we talk about the connected, now what does it mean? Normally we understand that when you get the data from a machine, you establish a connected system. But then when we are talking about connectivity, this is the first step actually. So where you are continuously pulling the location specific data with the help of the sensors, that is certainly the first step required. But more than that, how you will be building a data enabled collaboration in the real time between whether it's in a supplier and customer, or between within the organization itself. So between the different departments inside the organization. So connected means it's not just getting a machine connected and get the data out of it. It's more than that actually, how you will be enabling the different type of collaborations possible in the real time. Whether the information that is relevant from a production to quality is available in the real time, or something has been changed by the process engineering guy, whether this information is available to the maintenance person in the real time. So if this kind of information exchange happens in the real time, then we call it a connected enterprise. Then we will be doing all sort of collaborations based on the real-time data. Then we talk about the optimized, that we are running the facility at the optimum conditions. That is what I was mentioning as one of the challenge, that we don't run the facility in the optimal conditions most of the time. So in this case, we are talking about the reliable and predictable production capacity. This word is very important. When we say predictable production capacity, means that I am certain that my equipment is going to behave reliably and perform reliably so that I can make so many numbers in a day. So it means this is possible only when we run the facility in an optimized way. It means that when I say optimized, means I will be getting a high uptime. So I will be running my facility, as I displayed over here, more than 94%, 95% here, and then running at a higher production efficiency, the material handling being done automated with the minimal human interventions, so that we will be saving a lot of time in the changeovers. And we will be able to produce the right quality and with the right quantity, what is looking forward at the minimized cost. So unless you are able to do that, you will not be running the whole facility in an optimized way. Then we talk about the transparency, that once this data enabled collaborations is possible in the organization, then all decision making are happening based on this real-time information. They are not guess actually, they are not coming from just experience. They are certainly, experience is important, but then this experience is clubbed with the real-time information and what are the facts available, what is the actual data, and what is the insight that you are getting out of that. So this kind of live metrics basically is helping you to take a better decision making and a consistent decision making. It's not just 2% differently taking two different decisions, because if they are based on the similar data and insight, then they are converging to the same decisions. Then you can have better demand and forecast, the customer demand forecast possible once you have a connectivity with the customer, and then real-time data is being available to you. And then certainly in case where you are tracking the various activities during the supply chain, that is also possible too. So you are building, so transparency, certainly the IT systems build a lot of transparency in the whole system. So whether it's in a train services or it's any other consumer services, transparency basically build more loyalty in the customer. So they get to know about that, where the things are and where the situation, even the, in case of a train tracking system itself, we know that, say, if the train is now can be tracked in the real time, the customer at the station and the platform is now feeling comfortable actually, because he know that this is going to reach. It's not completely based on the announcements. He can easily see that whether it has left the previous station or not. So this kind of a transparency is very important in the system. So we are also looking forward for such transparency in the manufacturing systems. Then quickly we talk about the proactive feature here. The proactive characteristics means that you are detecting the anomaly in the system, and then once you are predicting the anomaly in the system with the help of the data that is coming to you, you will be proactively taking action. You will be preparing the whole system in advance actually. So in that case, if the spare part is going to be replaced, if the part is going to be replaced, you will be ensuring that the replenishment of that or restocking of that component will happen automatically. So the system will be triggering those activities in time. And more important, how you will be able to detect the quality issues at the supplier end. It's not just in your own facility, because you are also dependent on the suppliers who will be supplying these materials, and finally you will be assembling or you will be doing the final manufacturing activity at your premises. But before the component comes to you, you will still be able to analyze the information at the supplier and come to know that, yeah, this lot is not as per the quality standard we are looking forward. So before they reach to your premises, you can stop that activity and you can monitor, and then you can take a corrective action in advance so that last moment surprises will not happen. So these kind of proactive steps are important characteristics of the smart manufacturing. And certainly the safety is another important measure that we would like to implement. So real-time monitoring of the safety, so that you can take action before the actual situation comes for an accident, that you can take in advance. Those actions can be possible. Lastly, I will be talking about the agility, because we are talking about the flexibility in manufacturing. You may not be doing the mass production of the same goods that are being produced earlier. Otherwise, we will not be migrating towards the Industry 4.0. We would like to have more flexible and adaptive scheduling. So certainly the real-time changeovers can be possible. Real-time product mix can be produced in this case. And when we are creating a new facilities, we are looking forward for the configurable factory layouts, because that's the only way you can bring out the agility in the system. So based on the new products and product mix, the facility can be aligned themselves or can be made to align to produce a particular mix of the components. So that is what the agility, which is more important, because now in future, we are not too much going to be dependent on the same mass production. The product mix has to be changed as per the customer requirements. So agility is another important characteristic will come up once we implement these technologies. So for today, I will be just stopping my session over here. I will be continuing further whenever my session time will come, because we have another esteemed speaker from the industry waiting for the next session. So I'm just stopping over here. Over to you, Amit.
Thank you, sir. Thank you for enlightening session. So I would now request Mr. Kalyan Ram to take over the session for case study on convergence of automation and IIoT.
Yeah, thanks so much, Amit. Hello, Dr. Jha. How are you? Hello, everybody, all participants.
Yeah, thanks.
Yeah.
A brief about Mr. Kalyan Ram. Mr. Kalyan holds a bachelor degree in electronics and communication engineering. He also holds a master's degree in embedded system design. Mr. Kalyan is currently pursuing PhD on remote access and communication of devices and machines. Mr. Kalyan Ram is the co-founder of Electrona Solutions Private Limited. As the CEO, Mr. Kalyan provides strategy and insights drives innovations, defines organizations' business goals, and ensure business development. He is also the president of International Association of Online Engineering, Austria. Mr. Kalyan also heads the engineering design team at Electrono. Over to you, sir.
Thanks so much, Amit. Thank you. It's indeed a pleasure to be a part of this August House wonderful team. I believe that a lot of participants are from Indian Railways, so I'll try my best to give you examples and analogies associated with that. Having said that, I will start sharing my screen. Hope it is visible. So we are today talking about convergence of automation and industry 4.0 or industrial IoT, if you want to term it either ways. So I would talk it in the context of multiple elements. But before I start that, I will just give a small brief introduction about Electrono. Electrono as a company was established in 2011. We work extensively on industry 4.0 solutions with several products and multiple customers, including the Indian Railways. We've been ranked among the top 10 best IoT companies in India for 2020 by CIO Review magazine. Prior to starting Electrono in 2011, I was also working with Fanuc. Some of you might be familiar with Fanuc as a robot and controller manufacturers. And subsequently, I was working with GE in the control system design space and the R&D space on some of the control architectures. And then in 2011, we started Electrono. So as I mentioned, at Electrono, we've been having proven expertise in Industry 4.0 with successful implementations across Honda, Toyota, Mahindra, Hyundai, as I mentioned, Indian Railways as well, among others. So what I would like in terms of automation and industrial IoT, I will just touch upon predominantly the role, the need for manufacturing excellence, because ultimately all of these solutions, whether it is automation or whether it is industrial IoT or the so-called fourth industrial revolution, is all aimed at one thing. How do we do things better than what we are doing today? So as you all know, Kaizen as a terminology, it's for continuous improvement. So obviously this is also a source of continuous improvement. It is also an evolution from what we have been doing in the past. Several times, many of the conversations I have come across this terminology that industry 4.0 के बारे में भी बात कर रहे हैं, लेकिन अभी industry 3.0 ही पूरा implement नहीं हुआ है. So these kind of things come up. ये जरूर है ऐसा situation कि first level automation complete नहीं हुआ तो अभी industry 4.0 कैसे हो जाएगा. लेकिन बात ये नहीं है कि हम कैसे जंप करेंगे. आपको पता ही होगा कि जब कम्युनिकेशन टेक्नोलॉजीज में ऐसे डिफरेंसेस आने लगे, दैट यू माइट रिकलेक्ट एंड यू माइट रिमेंबर कि एक सिचुएशन था लैंडलाइन टेलीफोन्स. लैंडलाइन टेलीफोन होने के बाद ग्लोबली अगर देखा जाए, मतलब आप वेस्टर्न वर्ल्ड में देखा जाए, तो वहां पे बीच में एक टेक्नोलॉजी आया था पेजर्स. यहाँ पेजिंग सिस्टम होता था जहाँ पे आपको एक मैसेज अगर डिलीवर करना है किसी को, तो वो टेक्स्ट फॉर्म में उनके पास पेजर करके एक डिवाइस रहेगा, उसमें टेक्स्ट फॉर्म में आएगा, वो देख के वो मतलब मोबाइल कहीं पे भी जा रहे हैं तो हो जाएगा. Subsequently they can communicate back by calling the person who tried to reach them. बाद में ये पेजर का भी टेक्नोलॉजी काफी साल रहा वेस्टर्न वर्ल्ड में. बाद में मोबाइल टेक्नोलॉजी आने लगा. बट इन इंडियन कॉन्टेक्स्ट इट इज अ सरप्राइज दैट हमने तो पेजर का जमाने को हमने जंप कर लिया एकदम. इन इंडिया इट वाज लैंडलाइन, बाद में डायरेक्टली मोबाइल. ये बीच का पेजर का जो टेक्नोलॉजी था वो गायब ही हो गया था. तो ऐसे टेक्नोलॉजी एवोल्यूशंस में अक्सर ऐसा होता है कि एक टेक्नोलॉजी का एवॉल्व होने के बीच में दूसरा उससे भी बेहतर टेक्नोलॉजी अगर आ जाए तो अपने आप वी विल इवॉल्व टू दैट बेटर टेक्नोलॉजी. सो आई थिंक इन मेनी वेज ये इंडस्ट्री 4.0 इज आल्सो, और द फोर्थ इंडस्ट्रियल रेवोल्यूशन इज परसीव्ड इन मेनी वेज इन दैट कॉन्टेक्स्ट. हाँ, एक चीज है कि कहीं कहीं ऑटोमेशन एलिमेंट्स का जरूरत पड़ेगा, वो मैंडेटरी रहेगा, लेकिन फिर भी कई ऐसे चीजें हैं, कई ऐसे पॉसिबिलिटी है जहां पे आप डायरेक्टली जंप कर सकते हैं टेक्नोलॉजी का. तो From your perspective in Indian Railways, I will touch upon the manufacturing side of of this application. As you all know, Industry 4.0 can be applied both on running trains, which is rolling stock, as well as on manufacturing side of this entire infrastructure. So I will touch upon the manufacturing side to begin with, and then based on your questions, we can handle both sides. तो प्रोडक्शन में अगर टच करें तो प्रोडक्शन में ऑल द वे फ्रॉम कोच मैन्युफैक्चरिंग, व्हील एंड एक्सल मैन्युफैक्चरिंग, जहाँ पे आपका रॉ मटेरियल मोल्टन मेटल से लेके आपका फिनिश्ड गुड का जो फॉर्मेशन होता है एज ए कैस्ट आयरन or as as machining process that gets involved in the later stage on the axle and wheel, या आपका फर्निशिंग शॉप में जहाँ पे आपका कोच मैन्युफैक्चरिंग होगा, या आप लोकोमोटिव इंजीनियरिंग में जाएंगे तो लोकोमोटिव साइड में बहुत सारे एलिमेंट्स होंगे जहाँ पे लोकोमोटिव असेंबली हो या लोकोमोटिव लोकोमोटिव टेस्टिंग हो। बहुत सारे ऐसे चीजें हैं जहाँ पे टेक्नोलॉजी के हेल्प से बहुत चीजें जो अभी हो रहे हैं इट कैन बी डन मच बेटर, बेहतर परफॉर्मेंस ला सकते हैं उसमें। मेंटेनेंस एक बहुत बड़ा चीज है। इन मेंटेनेंस देयर आर लॉट ऑफ चैलेंजेस, यू नो दैट द आइडिया ऑफ मेंटेनेंस इज टू facilitate complete availability of machine and infrastructure without failing. वो हमको मैन्युफैक्चरेबिलिटी बेनिफिट करने के लिए अवेलेबिलिटी बहुत इंपॉर्टेंट होता है कि मशीन अवेलेबल हो पहले, उसके बाद उसमें प्रोडक्शन निकाला जा सकता है। तो अवेलेबिलिटी रखने के लिए बहुत सारे एफर्ट डालना पड़ती है, बहुत सारे प्लानिंग करनी पड़ती है। तो उस सेक्टर, उस डायरेक्शन में क्या हेल्प मिलेगा टेक्नोलॉजी के माध्यम से, that is another thing we will touch upon. Quality is the big piece. आपको पता ही है कि क्वालिटी में बहुत सारे चीजें होते हैं। इनलाइन क्वालिटी होता है, स्टैटिस्टिकल क्वालिटी होता है जो आप स्टैंडर्ड्स रूम में करते हैं, बहुत सारे क्वालिटी टेक्निक्स होते हैं, रॉ मटेरियल क्वालिटी होता है, इनकमिंग क्वालिटी इंस्पेक्शन होता है। तो ये सब चीजों में कैसे हम डिजिटाइज कर सकते हैं। और सब्सिक्वेंटली सेफ्टी, सिक्योरिटी एंड कंप्लायंस, आपका चेक शीट्स हो, आपका स्टैंडर्ड ऑपरेटिंग प्रोसीजर्स हो, या आपका डॉक्यूमेंटेशन हो, ऑडिट वेरिफिकेशन सिस्टम्स हो, ये सब के लिए आपको कैसे कंप्लायंस रखने के लिए कैसे डिजिटाइज कर सकते हैं। ये सब फैक्टर्स हैं मैन्युफैक्चरिंग एक्सीलेंस अचीव करने के लिए। इसमें बहुत सारे टेक्नोलॉजीज का उपयोग हो सकता है, जैसे कि इंडस्ट्रियल आईओटी प्लेटफॉर्म जहाँ पे आपका सेंसर्स लग सकते हैं, आपके मशीन्स को कनेक्ट करते हैं। मशीन कंट्रोलर्स जो है पीएलसी कंट्रोलर या सीएनसी कंट्रोलर है, उसमें से डायरेक्टली डेटा निकाला जाता है, जहाँ से आपको सिस्टम परफॉर्मेंस और सिस्टम अवेलेबिलिटी के बारे में बहुत ज्यादा इंफॉर्मेशन मिल जाएगा। ये मैं अभी आपको ऑटोमेशन और आईआईओटी में ये जो अंतर के बारे में और उसका जो कन्वर्जेंस के बारे में डिस्कशन होता है, उसको भी मैं थोड़ा सा डिटेल में आपको एक्सप्लेन करूंगा। जैसे ऑटोमेशन हो, ऑटोमेशन में बहुत सारे टाइप्स ऑफ ऑटोमेशन होते थे। आप अगर इंडस्ट्री 3.0 जनरेशन का लेंगे तो वहाँ पे मूवमेंट ऑफ मटेरियल का ऑटोमेशन होने के लिए रोबोटिक्स यूज होता था, जहाँ पे आपका ऑपरेटर एरर्स को कम करने के लिए ह्यूमन एरर इंट्रोडक्शन इन टर्म्स ऑफ ऑपरेशन, जैसे लोडिंग अनलोडिंग हो या वेल्डिंग हो या आपका पेंटिंग हो, या अलग जो एक पर्टिकुलर ऑपरेशन बेस्ड अप्रोच होता था, उसको ऑटोमेट करने के लिए जो टेक्नोलॉजीज यूज होते थे वो होता था रोबोटिक्स। प्रेडोमिनेटली डिफरेंट टाइप्स ऑफ रोबोट्स, ऐसा नहीं कि सब कुछ आर्म बेस्ड आर्टिकुलेटेड रोबोट हो, पिक एंड प्लेस रोबोट्स हो सकता है, कार्टेशियन कोऑर्डिनेट हो सकते हैं, बहुत सारे रोबोटिक मेथड से ऑटोमेशन होता था, इवन कन्वेयर बेल्ट भी हो सकता है। सब्सिक्वेंटली ऑटोमेशन इवॉल्व हुआ स्कैडा में, तो आपको स्कैडा के बारे में पता है। आपको स्कैडा इम्प्लीमेंटेशन होता था फॉर अ ग्रुप ऑफ मशीन्स और ग्रुप ऑफ ऑपरेशंस। तो ऑब्वियसली इंडस्ट्रियल आईओटी उसका भी एक एवोल्यूशन है आगे जाके, नॉट जस्ट ग्रुप ऑफ मशीन्स, इट कैन बी ग्रुप ऑफ लाइंस, ग्रुप ऑफ शॉप्स, ग्रुप ऑफ मैन्युफैक्चरिंग फैसिलिटीज, अक्रॉस मल्टीपल लेयर्स कम्युनिकेशन एस्टैब्लिश होता है। और इन सबसे ज्यादा एक और क्रिटिकल फैक्टर है स्काडा और इंडस्ट्रियल आईओटी के बीच में जो अंतर है, वो है स्पेसिफिकली एस्टैब्लिशिंग हिस्टोरिकल डेटा कनेक्शन विद रिस्पेक्ट टू करंट ऑपरेशन। मतलब आपको स्काडा में मेजॉरिटी क्या होता था, लाइव डेटा दिखता था और हिस्टोरिकल डेटा थोड़ा बहुत स्टोर होता था, लेकिन उनके बारे में जो कोरिलेशन या उनके एनालिसिस जो होना है वो उसमें ज्यादा हद तक उसमें वो कंपोनेंट नहीं था। अभी इंडस्ट्रियल आईओटी में क्या होता है, इन एडिशन टू हैविंग हिस्टोरिकल डेटा, आपको इनका कोरिलेशन भी आता है। दैट इज अनदर बिग पीस व्हिच कम्स इन इंडस्ट्रियल आईओटी। Big data analysis and algorithm, ये एक and advanced algorithm is one big part of this whole gamut of industry 4.0, जहाँ पे automation का components are also involved. HMI, आपको पता है कि आपने बहुत सारे HMIs advancements देखे हैं। HMIs में पहले के HMI बहुत text based होता था, ज्यादा कुछ graphics नहीं होते थे और उसमें सिर्फ एक information मिलता था। अभी का जो HMIs है उसमें बहुत ज्यादा ग्राफिक्स आने लगे, उसमें बहुत चीजें आप सेलेक्ट भी कर सकते हैं, मतलब ह्यूमन इंटरेक्शन के लिए बहुत फैसिलिटेट होता था, जहां पे आप कॉन्फ़िगर कर सकते थे बहुत सारे चीजें, जैसे प्रोग्राम सिलेक्शन कॉन्फ़िगरेशंस, जैसे टू लाइफ मॉनिटरिंग कॉन्फ़िगरेशंस, ये सब अभी के बहुत सारे HMIs इन द लास्ट 10-15 ईयर्स उसमें आप कर सकते थे। उसी का एडवांसमेंट अभी जाके होने लगा ट्रेसेबिलिटी में। ट्रेसेबिलिटी एक बहुत बड़ा चीज हो गया है अभी, बिकॉज फेलियर जब होता है, कभी एक फील्ड में फेलियर निकला या कुछ कस्टमर यूजर साइड में से फेलियर निकला, तो ये बहुत इंपॉर्टेंट होता है हमको कि ये रूट कॉज ऑफ फेलियर क्या है और उसको कैसे अवॉइड किया जा सकता है। तो इसको कायम रखते हुए ये बहुत इंपॉर्टेंट होने लगा कि ट्रेसेबिलिटी एंड जीनियोलॉजी बिकम्स very very critical. It is an extensively important part. So to differentiate between traceability and genealogy, genealogy is in one major part, उसका जो child parts होते हैं, जितने सारे child parts होते हैं, उसको connect करते हुए एक parent part या एक product को link करने के लिए that becomes genealogy. For example, आपका एक coach है, coach का एक coach number है, ये coach number में बहुत सारे चीजें fit हुए हैं, जैसे आपका axles fit हुए हैं, उनका बॉल बेरिंग्स फिट हुए हैं, या फर्निशिंग हुआ है, या एयर कंडीशनिंग हैचबैक हुआ है, और लाइटिंग सिस्टम्स कनेक्ट हुए हैं। तो इतने सारे चाइल्ड पार्ट्स एक कोच के अंदर फिट हुआ है। तो अगर आप एक कोच सीरियल नंबर आप निकालेंगे तो उनसे हमको यदि ये पता चले कि इसमें एक्सल कौन सा फिट हुआ, उसका सप्लायर कौन था, इसमें हैचबैक कौन सा फिट हुआ, उसका सप्लायर कौन था, ये कब फिट हुआ, किस असेंबली लाइन में फिट हुआ, कौन था ऑपरेटर उस टाइम पे, जब आपको ये सब इंफॉर्मेशन मिलता है, कंपोनेंट रिलेटेड इंफॉर्मेशन को हम जीनियोलॉजी बोलते हैं, टाइमिंग रिलेटेड इंफॉर्मेशन को हम ट्रेसेबिलिटी बोलते हैं। जस्ट टू नेम्स, बेसिकली देयर इज नॉट a significant thing. You can always call everything as traceability, but I am just telling you as terminology what is the difference between genealogy and traceability. Mobile devices are the key. आपको notification मिलना है, कोई भी shift मतलब मेंटेनेंस हेड हो या किसी को अगर इंफॉर्मेशन मिलना है कि कौन सा, या इवन एन एक्सपर्ट, पर्टिकुलर मेंटेनेंस इंजीनियर इज एन एक्सपर्ट इन पर्टिकुलर फील्ड, तो आपको उनका अगर सर्विसेज लेना पड़े तो पहले उनको इंफॉर्मेशन जाना चाहिए कि ये खराब हुआ है, then you can always have a communication and discussion around it. तो ये notification के लिए mobile device connectivity is useful. Similarly, cloud for across multiple locations and augmented reality एक method है जो बिना product को खोले आपको debug करने के लिए या आपको उसको diagnose करने के लिए एक तरीका है जिससे आपको बेहतर पता चले कि fault क्या हो सकता है और कहाँ पे आपको fix करना है। So क्वांटिफाइंग ऑफ डिजिटल ट्रांसफॉर्मेशन मतलब आपका चैलेंजेस और उनके मेन चैलेंजेस और उनके पर्सपेक्टिव से कैसे उसको एड्रेस किया जाए। सो फर्स्ट एंड फॉरमोस्ट द ऑब्जेक्टिव ऑफ ऑटोमेशन इज टू रिड्यूस ह्यूमन एरर, which is one of the major source of quality concern or performance issues. So one of the main source is definitely human error. तो ह्यूमन एरर को कम करने के लिए एक फैक्टर है ऑटोमेशन रिक्वायरमेंट है। सिमिलरली ह्यूमन एरर कम करने के लिए एक फैक्टर है कि जो डेटा है, डेटा इंफॉर्मेशन है और डेटा सोर्सेस है, वो भी ऑटोमेट होने का वही एक रिक्वायरमेंट है ताकि ह्यूमन एरर को कम करें। जैसे ह्यूमन एरर रिड्यूस हो जाएगा, उसका प्रोपोर्शनल डाउन टाइम रिडक्शन भी एक्सपेक्ट कर सकते हैं। दैट इज प्योरली फ्रॉम द पर्सपेक्टिव of availability of the system for performance. So हमने खुद ऑब्जर्व किया हमारे कस्टमर प्लेस में जहाँ पे इम्प्लीमेंट हुआ है, आपको डाउन टाइम लॉस रिडक्शन बाय अप टू 40% आप कम कर सकते हैं। ये डेटा है, इसके लिए मैं थोड़ा आपको लाइव एग्जांपल भी दिखा दूंगा। यू कैन हैव अ लुक एट some of these live examples and how it has helped to improve performance, reduce downtime, and provide more efficiency, which is overall equipment effectiveness at the end of the day, which is a product of performance, availability, and quality. So इनका जो प्रोडक्ट बनती है OEE, उसको इम्प्रूव करने के लिए भी बहुत सारे बेनिफिट्स है। सब्सिक्वेंटली एक बहुत बड़ा इंपॉर्टेंट पॉइंट है कि जैसे हमने डिजिटाइज किया, उस डेटा के माध्यम से हमारा ट्रेनिंग बहुत एफिशिएंट होता है। जैसे हमारा ऑपरेटर्स हो या मेंटेनेंस इंजीनियर्स हो, उनको बेहतर ट्रेनिंग मिलेगा और बेहतर परफॉर्म करने की एक एक प्लेटफॉर्म मिलेगी। क्योंकि आपको जो भी करना है, पहले आप स्टडी कर सकते हैं, आप डेटा देख सकते हैं, प्रिपेयर हो सकते हैं कि ये जाके हमको ये करना है, इस पर्टिकुलर पॉइंट में हमको फिक्स करना है। तो वो सब करने से आपका डायग्नोस्टिक टाइम जो है, जो पहले लेता था, मान लीजिए एक पर्टिकुलर ब्रेकडाउन को इवेल्युएट करके एनालाइज करने के लिए अगर आपको 2 घंटा लगता था, अभी डेटा के माध्यम से आपको इस टाइम को बेहतर कम कर सकते हैं, एटलीस्ट 40% कम कर सकते हैं। ये हमारा ऑब्जर्वेशन है। सो टिपिकल आपका एप्लीकेशन सिनेरियोज होंगे, जैसे CNC मशीन्स हो या रोबोट्स हो या कोई भी ऑपरेशनल मशीन्स हो, उनमें से क्या क्या टिपिकल चैलेंजेस आप एड्रेस कर सकते हैं फ्रॉम मेंटेनेंस पॉइंट ऑफ व्यू, आल्सो फ्रॉम प्रोडक्शन पॉइंट ऑफ व्यू। फर्स्ट आई टॉक एंड क्वालिटी एज वेल। पहले मेंटेनेंस टच करता हूँ, फिर प्रोडक्शन में एक ब्रीफ लेता हूँ और फिर क्वालिटी। सो यहाँ पे आप एक एक पॉइंट में आप आइडेंटिफाई कर सकते हैं कि ऑटोमेशन के माध्यम से और ऑटोमेशन का कन्वर्जेंस कैसे हो रहा है IIT में। पहले फर्स्ट लेवल ऑफ ऑटोमेशन इज टू हैव अ कंप्यूटर न्यूमेरिकली कंट्रोल्ड सिस्टम्स, मतलब मशीन में ही आपको एक डिजिटल सिस्टम रहेगा। जैसे CNCs आपको पता है, CNC एक कंट्रोलर है, तो मशीन में अगर CNC है तो वो फर्स्ट लेवल ऑफ ऑटोमेशन हो गया। नहीं तो इससे पहले क्या होता था, मैनुअल मशीन्स होते थे, तो उनमें मैन्युअली सेटिंग्स करना पड़ता था, मैन्युअली ऑपरेट करना पड़ता था। तो फर्स्ट लेवल ऑफ ऑटोमेशन आपको आ गया मशीन के ऊपर CNCs के माध्यम से। जैसे आपका CNC लग गया, दैट इज ऑटोमेशन स्टेज, उसको हम कैसे कन्वर्ट करेंगे IIoT के स्पेस में। मान लीजिए कि आपका मल्टीपल कंट्रोलर्स आपके शॉप में हो, मतलब आपको भी पता है आपके कुछ फैक्ट्री या लंबे लंबे शॉप्स जो है वो एक एक बे आपको जाएगा 300-500 मीटर 600 मीटर तक का लंबी रहता है, और उसमें इतने सारे मशीन्स रहते हैं, इतने सारे कंट्रोलर्स रहते हैं। ऐसा तो प्रैक्टिकली ह्यूमनली इम्पॉसिबल है कि आप जाके एक एक मशीन का प्रिवेंटिव मेंटेनेंस करेंगे, वो भी एक एक पैरामीटर को, मतलब आप कर रहे हो, अभी मुझे पता है कि फिलहाल वैसे हो रहा है, लेकिन वो एफिशिएंट नहीं है, वो आपको भी पता है कि इसमें बहुत सारी दिक्कतें हैं। सो इफ यू आर एबल टू कनेक्ट ऑल दीज कंट्रोलर्स एंड ऑल दीज मशीन्स, आपका इमीडिएटली पीएम एफर्ट कम हो जाएगा। जैसे तुरंत आपको पता चल जाएगा कि इस मशीन में बस ये वाला पीएम आपको एग्जीक्यूट करना है, बाकी सब ठीक चल रहा है। सो यू कैन एक्चुअली ऑप्टिमाइज योर प्रिवेंटिव मेंटेनेंस शेड्यूल। सब्सिक्वेंटली इसके बाद में आपका प्रिवेंटिव मेंटेनेंस, ये लो हैंगिंग फ्रूट है आपको, मतलब इसका तुरंत फायदा मिलेगा। आपका पीएम का जो मेंटेनेंस इंजीनियर है, 3 मेंटेनेंस इंजीनियर है, 150 मशीन को हैंडल कर रहे हैं, ऑब्वियसली उनका डेली रोटेशनल एक्टिविटी जो है, यहाँ पे उनको हर एक मशीन के ऊपर जाके इतना इतना पीएम करना पड़ेगा, उसको तुरंत आप ऑप्टिमाइज करके उस मेंटेनेंस इंजीनियर का एफिशिएंसी बढ़ा सकते हैं। सो द मेंटेनेंस इंजीनियर कैन डू मच मोर यूजफुल वर्क। ये एक इमीडिएट बेनिफिट हो जाएगा, लो हैंगिंग फ्रूट, जो प्रिवेंटिव मेंटेनेंस शेड्यूल को ऑप्टिमाइज करे। टूल लाइफ मैनेजमेंट एक बहुत बड़ा चीज है। आपको पता है कि टूल लाइफ मैनेजमेंट डायरेक्टली ट्रांसलेट्स इनटू क्वालिटी। आपका अगर टूल डिटोरेट हुआ, वो टूल ठीक टाइम पे रिप्लेस नहीं हुआ, तो तुरंत आपको खराब क्वालिटी निकलेगा प्रोडक्शन में। तो ये एक बहुत बड़ा इंपॉर्टेंट चीज है जो टूल लाइफ मैनेजमेंट को ट्रैक करके उसको ऑप्टिमाइज करके सेंट्रली आपका टूल इशू सिस्टम जो है उसी में एक ऑटोमेटिक वे ऑफ आइडेंटिफाइंग कौन से मशीन में कौन सा टूल्स अभी इशू होना है, वो एक फुली डिजिटल प्लेटफॉर्म वो फैसिलिटेट कर सकता है। इंसुलेशन रेजिस्टेंस एक और चीज है, आपको पीएम में भी ये आइडेंटिफाई करना बहुत मुश्किल हो जाता है। तो इस एक पर्टिकुलर मोटर के अंदर एक पर्टिकुलर वाइंडिंग में अगर थोड़ा सा एक लीकेज है, it is so difficult even for a experienced maintenance person to identify these kind of things. पता है आप जाके मेजर करोगे, हर एक मशीन में, हर एक मोटर में ये सब करना बहुत मुश्किल है। तो इंसुलेशन रेजिस्टेंस डिटेक्शन हो जाएगा ऑटोमेटिकली थ्रू द CNC कंट्रोलर, एंड आपको रिपोर्ट मिल जाएगा कि ये वाला मशीन में, ये वाला मोटर में ये इतना इंसुलेशन डिटोरेशन हुआ है। तो आपको सिर्फ जाके उस मोटर को एड्रेस करने से आपका इफेक्टिव काम खत्म हो जाएगा। प्रिडिक्टिव मेंटेनेंस, डॉक्टर झा ने इसके बारे में भी बहुत बताया कि प्रिडिक्शन कैसे होता है, उसके लिए क्या फीचर्स हैं। सो यू कैन एक्चुअली स्टार्ट, सोच लीजिए आप, ऐसा एक सिचुएशन आएगा कि आप बैठे बैठे एक जगह पे बैठे बैठे आपको पता चल जाएगा कि आपके इतने सारे 150, 300, 500 मशीन्स में एक पर्टिकुलर मशीन में एक पर्टिकुलर आने वाला है प्रॉब्लम, एक पर्टिकुलर प्रॉब्लम आने वाला है। और वो भी कब आएगा, मान लीजिए एक हफ्ते, अभी से एक हफ्ते में उसका बॉल स्क्रू जो है शायद वो उसमें ओवरलोड हो रहा है तो वो स्नैप हो सकता है, या बेरिंग्स में डिटोरेशन आ रहा है। तो ये सब चीजें भी आप एक्चुअली आइडेंटिफाई कर सकते हैं विद द हेल्प ऑफ टेक्नोलॉजी। तो इसके लिए कॉम्प्लेक्सिटीज को आइडेंटिफाई करके उसका उस पर्टिकुलर मशीन में कितना इंपॉर्टेंस है, इतना प्रेडिक्टेबल नेचर डिफाइन करना, उसका फेल्यूर रेट क्या है, वो सब आइडेंटिफाई करके आप हाई लेवल ऑफ प्रेडिक्शन भी उसमें इंक्लूड कर सकते हैं। सो एक और इम्पॉर्टेंट चीज होता है अलार्म एनालिसिस। जैसे आपको पता ही है इतने सारे मशीन्स चलते रहेंगे एक साथ तो बहुत सारे अलार्म्स आते रहेंगे। कभी कभी ऑपरेटर उनके लेवल में वो रीसेट करके वो चालू भी कर देते हैं मशीन और चला भी लेते हैं, लेकिन मेंटेनेंस डिपार्टमेंट या मेंटेनेंस इंजीनियर को पता भी नहीं चलेगा कि ऐसा एक अलार्म आया था। जस्ट दैट कुड हैव बीन अ स्टार्टिंग पॉइंट ऑफ डिटोरेशन, दैट कुड हैव बीन अ स्टार्टिंग पॉइंट ऑफ अ डिजास्टर्स फेलियर। लेकिन वो इंफॉर्मेशन मेंटेनेंस डिपार्टमेंट तक शायद नहीं पहुंचेगा। तो ऐसे एक डिजिटाइज करके कम्युनिकेट करके सारे ट्रांसफर करने से you will have an analytical approach to alarm analysis। जैसे आपको पता चलेगा कि 3 अलार्म ऐसे आए हैं, उसका कोरिलेटेड वर्जन शायद हो ओवरहीटिंग अलार्म हो, या ओवर करंट अलार्म हो, या लिमिट एक्सीडिंग अलार्म हो, मतलब ओवर ट्रैवल लिमिट, जो भी है, you will be able to identify precisely what is the action you have to take, ताकि फ्यूचर प्रॉब्लम्स को अवॉइड कर सके। ये सब करने के लिए ऑटोमेशन और इंडस्ट्रियल आईओटी में मेन चीजें, मेन एलिमेंट्स, डिफरेंसेस क्या है। तो ऑटोमेशन में आपको भी पता है कि स्कैडा लेवल में आप अगर लेके जाएंगे तो स्कैडा में आपने ऑब्जर्व किए होंगे कि कई सारे 1, 2, 3 मशीन, आसपास वाले मशीन या एक सेल जो भी है आपका, उसको कम्युनिकेट करते हुए एक लेवल ऑफ स्क्रीन डेवलप किया जाएगा जहाँ पे आपको पर्टिकुलर इंफॉर्मेशन डिस्प्ले हो जाएगा और अकॉर्डिंगली रियल टाइम इंफॉर्मेशन ऑब्जर्व करने के लिए आपको मिलेगा। उसमें थोड़ा बहुत क्या बोलते हैं, थोड़ा बहुत ऑटोमेशन एलिमेंट्स भी रहेंगे, जैसे व्हाट इज ओके, व्हाट इज नॉट ओके, टाइप्स ऑफ अलार्म्स, पोके ओके, ये सब इम्प्लीमेंटेशंस आपको स्काडा में एक लेवल तक मिल जाएगा। आगे जाके इंडस्ट्रियल आईओटी में एडिशनल एलिमेंट्स क्या है। एडिशनल एलिमेंट्स ये है कि अक्रॉस मल्टीपल सिस्टम्स, आप नॉर्मली ऑब्जर्व करेंगे स्काडा में इट विल बी मोर और लेस कॉमन सिस्टम्स दैट आर कनेक्टेड। बहुत ज्यादा डिफरेंशिएटेड सिस्टम्स में कनेक्ट करने में बहुत मुश्किल होता है स्काडा में भी। फिर भी जेनेरिक कॉमन सिस्टम्स आर द ones which are normally connected. Of course, there are SCADAs wherein you have the facility to connect very different systems also, but that is an evolution of SCADA towards IIoT, actually speaking. तो यहाँ पे फिजिकल लेयर में आपको बहुत सारे टाइप्स ऑफ मशीन्स, ऑल द वे फ्रॉम CNC मशीन्स, क्रेन्स, कंप्रेसर्स, transformers, chillers, STPs, ETPs, including ERP, can be integrated into a common platform from IoT perspective. ये सब नेटवर्क होके, एक्चुअली एक और चीज है कि नेटवर्किंग प्रोटोकॉल्स जो यूज हो रहे हैं वो भी बहुत एडवांस हुए हैं, ट्रांसफर रेट बहुत ज्यादा है, ताकि आपको ज्यादा से ज्यादा इंफॉर्मेशन मिले मशीन लेयर से और सेंसर लेयर से। डिफरेंट सेंसर्स और सेंसर इंटीग्रेशन भी हो जाएगा इसके साथ। तो ये सब मिलके आपको एक IoT इंटरफेस और इंडस्ट्रियल IoT इंटरफेस मिलेगा। इसके साथ में आपको होगा एक मशीन लर्निंग प्लेटफॉर्म, डेटा वैलिडेशन फर्स्ट एंड फॉरमोस्ट, एंड एनालिटिक्स प्लेटफॉर्म। ये सब मिला के आपको कॉम्प्लेक्स नेक्स्ट लेवल ऑफ स्टोरेज और इंटरफेस में जाएगा। सो द बिग डिफरेंस बिटवीन SCADA and industrial IoT in this context is to be able to have a centralized data validation system and also analytical frameworks to handle high density data. SCADA में आपका density of data भी काफी low था. अभी because of protocol enhancements and because of evolution in communication methods and systems, आपको data density भी बहुत ज़्यादा होने लगा. Just some examples of how different things can be approached. अब यहाँ पे मिडिल में एक देख सकते हैं कि सेट ऑफ लाइंस एक जगह पे आपको देख के पता चल जाएगा कि ये वाला मशीन में अलार्म्स आ रहे हैं, वो क्लिक करने से आपको पता चलेगा कौन सा अलार्म आ रहा है. तो आपको प्रिपेयर्डनेस के लिए बहुत बेनिफिशियल रहेगा. और ये दिखाएगा आपको OEE in terms of performance, in terms of operating time, idle time, running time. तो ये सब चीज़ों से आपको एक एनालिटिकल इंफॉर्मेशन मिल जाएगा कि आपका एक पर्टिकुलर मशीन या एक पर्टिकुलर लाइन कैसे बिहेव कर रहा है, कैसे परफॉर्म कर रहे हैं, उसमें क्या रीजंस है वो रुकने के लिए. रीजन कोड करके एक बहुत बड़ा चीज है. अगर वो आइडल है या अगर वो ब्रेकडाउन में है, उसका रूट कॉज क्या है, उसका रीजंस क्या है. Is it because of unavailability of raw material? Is it because of operator not being present? Is it because of some breakdown in the machine? Or is it because of the machine running slow? तो ये सब चीजें रीजन कोड्स के हिसाब से वो मॉनिटर कर सकते हैं. Predominantly, I would now touch upon defining what do you mean by availability and what do you mean by maintenance. So as a definition, maintenance is a process of preserving a condition or situation of the state of being preserved. So basically, maintenance is a process of sustaining a particular machine, system or operation. और उसका उस माध्यम से availability becomes a very important factor. जैसे अब हमने बताया कि बहुत ज्यादा important चीज है कि maintenance में कि most of the times it is a fact that complex machines के साथ आप deal कर रहे हैं. It is quite obvious that we really don't have the complete understanding of every single type of machine all the time to be able to assess whether a given machine will operate or fail, or when it fails, what is the root cause and how do you fix it. तो इस particular ambiguity और uncertain situation को handle करने के लिए definitely alarm analysis and predictive maintenance is the approach. Lot of machine learning and artificial intelligence algorithms are involved in assessing and predicting the root cause of failures based on multiple alarms and the possibility of occurrence of those alarms, and helping you to take a decision कि इस particular machine या system में हम एक breakdown को कैसे avoid कर सकते हैं. And आप actually इसको unplanned breakdown को आप actually planned maintenance में convert कर सकते हैं. जैसे आपका मेंटेनेंस शेड्यूल है हर एक संडे को या हर एक सैटरडे को एक पर्टिकुलर शिफ्ट में आप मशीन को डाउन लेंगे और आप मेंटेन कर पाएंगे. तो ज्यादा से ज्यादा चीजें जो अनप्लान्ड डाउन टाइम कैटेगरी में आ रहा है उसको आप कन्वर्ट कर सकते हैं प्लान्ड डाउन टाइम लेके. That is one of the major part in all of these. With this, I would now move towards production. Production में आपको critical चीजें होते हैं. First and foremost, target. आपके हर एक प्रोडक्शन प्रोसेस में आपको एक वर्क ऑर्डर होता है, उसमें आपको एक पार्ट नंबर डिफाइन होके उसका कितना क्वांटिटी प्रोड्यूस होना है उसका टारगेट डेफिनेशन रहता है. उसके हिसाब से आपका एक साइकिल टाइम भी डिफाइन होता है ऑब्वियसली, एंड बाय दैट साइकिल टाइम यू आल्सो डिफाइन व्हाट शुड बी द number of parts that you need to produce, which is again defined as target, and then you have actual which says what was actually produced. और इसके लिए रीजन होता है sometimes or rather most of the times you will notice that actual will be lesser than the target, and there are reasons for that. And what are the reasons? That is the most important thing कि ये एक टारगेट अचीव करने के लिए जो शॉर्टफॉल आ रहा है उसका प्राइम रूट कॉजेस क्या होता है. कभी कभी ऐसा होता है कि there is a slow cycle, there is a slow running cycle, or there is a wait time, बहुत ज्यादा वेट टाइम है इधर रॉ मटेरियल के लिए या टूल्स के लिए, या फिक्सचर सेटअप टाइम बहुत ज्यादा है. तो बहुत ज्यादा चीजें ऐसे होते हैं वो जो डिफाइन करना बहुत मुश्किल होता है. जब तक आप प्रैक्टिकली जाके ग्राउंड में खड़े होके नहीं देखते, वो मतलब वो डिजाइन फेज में किसी को पेपर में बैठ के प्लान करने के लिए तो वो बहुत आसान होता है, लेकिन ग्राउंड लेवल पे आप देखते हैं तो बहुत सारे प्रॉब्लम्स होते हैं जिसकी वजह से एक्चुअल टारगेट को मीट करना मुश्किल होता है। तो उसको ट्रैक करके, उसके ऊपर ऑपरेट करके, उसको आइडेंटिफाई करके, हर एक पॉइंट के ऊपर इंप्रूव करने के लिए अगर एक फैसिलिटी मिलेगा, दैट इज द वन विच इज द मोस्ट इंपॉर्टेंट थिंग विद रेस्पेक्ट टू इंडस्ट्री 4.0। आपको यहाँ पे एक दिख सकता है, यू कैन सी इन द स्क्रीन दैट आई एम शेयरिंग, प्रोडक्शन हुआ है 159 मिनट्स, जहाँ पे आपको शॉर्ट मैनिंग मतलब 8 मिनट के लिए ऑपरेटर अवेलेबल नहीं था, एक पर्टिकुलर वाल्व का एक ब्रेकडाउन था, एक रोबोट का फॉल्ट था, स्लो साइकिल चल रहा था 5 मिनट के लिए, लेट स्टार्ट हुआ 0.8 मिनट्स, माइक्रोसॉफ्ट हुआ 2.4 मिनट। तो इसको हम एक्यूमुलेट करके एक पूरे शिफ्ट के अंदर या मल्टीपल शिफ्ट्स के अंदर एक पूरे हफ्ते में या एक महीने में टॉप 5 रीजंस क्या है जो परफॉर्मेंस को अफेक्ट कर रहा है, उसको आइडेंटिफाई करके यू कैन एक्चुअली स्टार्ट टेकिंग डिसीजंस। कहीं सारे चीजें ऐसे भी होते हैं जो आपका यू कैन गेट डाउन टू दिस लेवल ऑफ डिटेलिंग, जहाँ पे आपका पार्ट प्रोग्राम एफिशिएंट नहीं हो, आपका एयर कटिंग टाइम ज्यादा है एक्चुअल कटिंग से। तो ये सब पॉइंट्स आइडेंटिफाई करने के लिए दिस इज गोइंग टू बी द की फैक्टर। इट विल हेल्प यू आइडेंटिफाई दैट, और अपने आप आपको एक चेंज इंप्लीमेंट करने से आपका परफॉर्मेंस ऑटोमेटिकली बढ़ जाएगा। तो ऐसा मैंने जो आपको अभी बताया, दिस इज गोइंग टू डायरेक्टली ट्रांसलेट इनटू ओई, क्योंकि परफॉर्मेंस is one of the critical parameter of computation of OE. तो line wise और shift wise ये सब operate करके we should be in a position to define the metrics. Just give me one second. I'm just getting one call. I'll just respond. Yeah, sorry for that. I just had to respond to one particular situation. All right. So with this, you will have a performance-based evaluation and the top reasons. What are the top reasons for a given performance deterioration? इसका main reason के जैसे यहाँ पे आपको दिखाया जाएगा across 1 month when we take an analysis, or across even one single day when you take an analysis, you will see a scheduled downtime in minutes or hours, whatever you want, you can define. यहाँ पे clearly micro stoppage is coming as a second most important factor. तो हम इसके ऊपर एक top level of analysis करके हम identify कर सकते हैं कि micro stoppage क्यों हो रहा है, क्योंकि micro stoppage is not an expected scenario in a normal production environment. Similarly, आपको quality में yield loss में आप देख सकते हैं undersize components ज्यादा हो रहे हैं. So इसको हम आइडेंटिफाई करके अंडरसाइज क्यों हो रहा है, तो ऑब्वियसली देयर इज एन इम्पैक्ट बिकॉज ऑफ either offset और टूल इन टर्म्स ऑफ टूल परफॉर्मेंस. तो ये अंडरसाइज हो रहा है तो ऑब्वियसली इसमें ऑफसेट या टूल का कुछ इशू हो सकता है. तो ये सब के बारे में हम एनालाइज करके हम एक डिसीजन ले सकते हैं. So these are some of the main things. The rest of the things are all some examples of how different conditions can be observed. This is one important screen which I thought I will touch upon a little in detail, जहाँ पे आपको ये actual scenario जो है हमने खुद एक experience किया है, जहाँ पे एक accident हुआ था एक machine के अंदर, और हम उस particular accident scenario को लेके हमने study किया data के माध्यम से. इसका incidentally हमने यहाँ पे already digitize कर चुके थे और उसके माध्यम से हमको बहुत सारे data मिला जो हम स्टडी कर सकें, और हम ये पूरा स्टडी उसमें एक्सीडेंट टाइम के एक्सीडेंट का फ्यू मिनट्स बिफोर एंड फ्यू मिनट्स आफ्टर हमने जब डेटा निकाला और उसको स्टडी करने लगे, तो इट वाज बिकमिंग सो इंटरेस्टिंग कि हमको पता चला कि ये एक्सीडेंट क्यों हुआ, एक रूट कॉज क्या था। तो दिस वाज एक्चुअली अ थ्रू कूलेंट स्पिंडल हाई स्पीड मशीन। ये हाई स्पीड थ्रू कूलेंट स्पिंडल मशीन में क्या हुआ था, इसका कूलेंट पंप के सक्शन प्रेशर में थोड़ा वेरिएशन आया था। दैट कुड बी ड्यू टू सेवरल रीजंस, पावर सप्लाई फ्लक्चुएशन हो सकता है, या कूलेंट फ्लो में थोड़ा ऑब्स्ट्रक्शन हो सकता है। इसकी वजह से आपको सक्शन प्रेशर में वेरिएशन आ सकता है। तो उस सक्शन प्रेशर वेरिएशन इज अ रैंडम इवेंट। जब वो हुआ था, उसके करस्पॉन्डिंगली there is an interlock in the spindle that whenever the pressure drops below a particular value, the spindle should stop. This is a fair interlock, this is a fair condition. लेकिन उसके साथ साथ जब spindle stop होता है, there is a very important correlation that even the servo should stop. Only then that is the complete interlock closure. This is a very common basic understanding जो even 3-4 years experienced PLC programmer also knows this. that जब भी आप स्पिंडल को रोक रहे हो, आपको सर्वो को भी रोकना जरूरी है, वो इंटरलॉक पास करना जरूरी है। दिस इज अ कॉमन इंफॉर्मेशन, बट दिस ऑन एन इंपोर्टेड मशीन दिस पर्टिकुलर इंटरलॉक वाज मिसिंग। ये होता है कभी कभी, आई मीन दिस इज अ वेरी क्रिटिकल थिंग, लेकिन ये पर्टिकुलर सिनेरियो जब अकर होता है तभी ये क्रिटिकल होता है, और उसी की वजह से वो एक्सीडेंट हुआ था। तो इसको बहुत सारे बार ये एक्सीडेंट हुआ, कस्टमर को पता भी नहीं चला कि क्यों एक्सीडेंट हो रहा था। मोस्ट ऑफ द टाइम इट वाज एट्रीब्यूटेड टू ऑपरेटर, क्योंकि किसी को नहीं पता कि कैसे एक्सीडेंट हुआ, तो सबको ये लगने लगा कि ये कुछ ऑपरेटर ने गड़बड़ किया, ये हुआ वो हुआ, इसलिए एक्सीडेंट हुआ। लेकिन रूट कॉज ये था कि उसमें इंटरलॉक मिसिंग था। तो ये ऑपरेटर का गलती नहीं है, ये किसी और का मेंटेनेंस इंजीनियर का गलती नहीं है, ये सिर्फ जो इंपोर्टेड मशीन का जो मेन प्रोग्रामर है, उस प्रोग्रामर ने उसमें इंटरलॉक नहीं डाला था। हमने इसको आइडेंटिफाई किया, हमारे कस्टमर को इन्फॉर्म किया, कस्टमर भी एक्सेप्ट करने के लिए तैयार नहीं है, क्योंकि इंपोर्टेड मशीन था और वो लोग एक्सेप्ट करने के लिए तैयार नहीं है। हम ये कैसे बताएं कि उनके प्रोग्राम में गलती है। तो डेटा होने के एडवांटेज ये है कि आप बोलने की जरूरत नहीं है, प्रूफ सब कुछ आपके साथ में है। हमने सिर्फ प्रूफ भेज दिया डायरेक्टली, कस्टमर ने भी उसी प्रूफ को फॉरवर्ड किया ओईएम को, और ओईएम को एक्सेप्ट करना पड़ा। पहले उन्होंने रिजेक्ट किया, बोले कि ऐसा हो नहीं सकता है ये वो, फिर बाद में डेटा देखने के बाद किसी को हिम्मत नहीं है कि ये गलत है, तो उनको ऑब्वियसली उसको आइडेंटिफाई करना पड़ा, उसके ऊपर काम करना पड़ा, उसको फिक्स करना पड़ा। और ये फिक्स करने के बाद कभी भी ये वाला एक्सीडेंट हमारे कस्टमर साइड में कभी नहीं हुआ। एंड नॉट जस्ट इन आवर कस्टमर साइड, दिस पर्टिकुलर OEM हैज इंप्लीमेंटेड दिस सॉल्यूशन अक्रॉस द वर्ल्ड। तो ऐसे भी होते हैं चीजें और सिचुएशंस जहां पे आपको डेटा एनालिटिक्स के माध्यम से ये सब आइडेंटिफाई किया जा सकता है। ऑब्वियसली इन earlier days technologies this was absolutely not possible. अभी के इंडस्ट्रियल IoT के माध्यम से ये एक बहुत बड़ा चीज है जो हम कर सकते हैं। तो these are some of the example dashboards, I'm just showing you कैसे दिखता है, क्या है, just for your information कि मोबाइल में भी इंफॉर्मेशन मिल जाएगा, अलार्म एनालिसिस मिल जाएगा। तो ये सब तो पॉसिबिलिटी है, ये मिल जाएगा बोलना अलग है। आपके रिक्वायरमेंट जो है उसके हिसाब से कैसे हम टेलर मेड सॉल्यूशन बनाएंगे, वो बहुत इंपॉर्टेंट चीज है। उसको एनालाइज करना बहुत इंपॉर्टेंट है, क्योंकि हर एक सिनेरियो में, हर एक कस्टमर के एक प्रोसेस में बहुत सारे वेरिएशंस रहते हैं। देयर इज नथिंग कॉल्ड एज वन साइज फिट्स ऑल। ऐसा नहीं है कि एक जगह पे जो इम्प्लीमेंट हो उसी को जाके बिना कुछ बदले या मॉडिफाई के जाके सीधा जाके दूसरी जगह पे डाल दोगे तो वो काम करेगा, ऐसा तो है नहीं। कस्टमाइजेशन का जरूरत पड़ेगा। फिलहाल in the current context of technology definitely there is a role for customization. ऐसा नहीं है कि आपने एक बार इंस्टॉल कर दिया तो सब कुछ चलेगा, ये भी नहीं है। So different elements of this in terms of key areas of focus अगर आप identify करना चाहते हैं तो I think these are some of the low hanging fruit fast cut implementation benefit areas, जैसे tool life management, daily machine check sheet, और alarm analysis and root cause analysis. ये तीन जो है, I think these three could be your first low hanging fruit start points in your journey for journey of digital transformation using Industry 4.0. I think with this, I would kind of pause and I would like to hear more questions. आपका कोई सिनेरियो है, आपका कोई एक्सपीरियंस है, आपको एक सिचुएशन है जो आप जानना चाहते हैं कि वो डिजिटल ट्रांसफॉर्मेशन के माध्यम से कैसे इंप्रूव किया जाए, अगर ऐसा कुछ है तो आई थिंक दैट इज मोर इम्पोर्टेंट, डिस्कशन करना बहुत जरूरी पड़ेगा. तो विद दैट आई वुड कम टू द एंड ऑफ माय क्विक सेशन on convergence of automation and industrial IoT in the Industry 4.0 scenario. Thank you. So if there are any questions, we could have a conversation. Amit, maybe you can check and suggest.
Okay, sir, I'll check it. Thank you for the enlightening the participants, sir. So now I would request Mr. Anup Wadhwa, sir, to enlighten us on project formulation. A brief about Mr. Anup Wadhwa. Mr. Anup Wadhwa is
Amit, you can share the screen, yeah.
Okay, sir. I'm sharing the screen, sir. Mr. Anup Wadhwa is an alumnus of IIT Delhi, from where he did completed his bachelor degree in technology in electrical and electronics in 1975. His passion for digital electronics started in college and later took him to an exciting career in the field of industrial automation. Mr. Wadhwa has served in BHEL, a premier public sector company, Rockwell Automation, a leading technology MNC, and Semtel. Currently responsible for creating the Samarth Udyog ecosystem, bringing in automation industry, machine builders, IT costs, integrators, and academia. Over to you, sir.
Thank you, Amit. Kalyan, I'm just going to use this session to connect with your questions. So kindly be available.
Sure. First of all, good evening to you too.
Yeah, good evening, Kalyan. And I think you have ramped up the program very well, and we are ending day one on a very positive note. So welcome again, all the railwaymen. Special occasion for me to reconnect with all of you in this third edition. My session is going to be very small, and it's not going to be a lecture per se. It is more of a wrap up of what we've done and how we are planning to leverage the learning using the project formulation approach. So Kalyan ended his lecture with this statement saying that please tell us where you want to deploy it, and then we can take the discussion forward. So that's really what the purpose is of making this learning a project-based learning approach. Some of you may have registered for this program purely to build awareness. Some others may be attending this program to build a specific competency in a particular area of technology or multiple areas of technology. And whereas some of you may be attending to actually, implement a project. I was listening to all your introductions, and I think, this entire group will fall between these three sort of constituencies. But whichever be your, motive, whether you are on the awareness building curve or competency building curve or implementation, what I assume is common is that all of you are going to be examining the relevance of this course to your current and future responsibilities, in fact, to your entire career, because Industry 4.0 is a disruption, and we'll know its impact, only in the next couple of years. So at this point, I want to take a little pause and ask 1, 2, or 3 of you to share with the group. The question I'm posing is, what is the shift you want in your understanding of cyber physical systems? Dr. Jha did explain that Industry 4.0 is about bringing the physical world and cyber world together in a highly integrated manner. So really speaking, if that is the context of understanding, what's the kind of shift you're wanting? Can we have some of the people raise their hands, and then I'll ask you to unmute and share. Should we start with the Eastern Railway? Can someone from Eastern or Southeastern start the process? Yes, we are waiting for somebody from the participants to respond.
Yeah. Good afternoon, Mr. Vajwa. I'm SK Yagnik. I'm Chief of Faculty Mechanical from NAIR, and essentially just sent an invitation call to all these participants. One of the areas which has come ready to my mind, I had a fair degree of exposure to the mechanical production systems and maintenance systems in railways. The amount of instrumentation in our working so far has been fairly low. Suppose we are assembling a bogie of a coach, locomotive or coach, and we are testing some kind of systems on the locomotive or air conditioning systems of coach or bogie vibration testing. The amount of instrumentation is so low that data pickup has not been considerable so far. So our real challenge at present is data analysis will come when we are able to generate data. So data generation we do, but those points are very, I would say, they are points and not the lines. And we are not able to connect the continuous pickup of data is so far not very easy. Suppose I am assembling a bogie, there may be about 50 or 70 checkpoints, out of which we do major checkpoints. We manually check about 50 to out of 50, we may be checking 5 or 10 major parameters. But the end of the day, it does happen that the rest of the 40 are left to the skills of the worker. So instrumentation is one area where unless we start from there, the data pickup will not really take place. So something, how we can start on that.
Perfect. So I think what you've given is an example of where most people need to start their journey is from the point of capture on a real-time basis and on an easy basis, so that they don't have to run after the data comes in. Incidentally, tomorrow's lecture is going to be on sensorization. So that will be something which you will pick up. The point is well taken that you are coming with a definite purpose in mind, and that's really how this project build-up will happen. And I'll share over the next few minutes some concrete milestones we have over the next 7-8 days. Thank you, Mr. Yagnik. Is there anybody else who wants to talk about maybe a different area, a non-assembly area, maybe a kind of something similar to what use cases Kalyan was saying?
Sir, Utkarsh from Chris.
Okay, from Chris, yeah.
Yes, sir. Sir, I have been in charge of projects in Indian Railways at Railway Board level. Like one case, like Yagnik sir said, that sensorization is at a very low volume in Indian Railways machineries. At the same time, whatever work we want to do, like all these things will require a lot of capital intensive inputs, I believe. So what is the compelling economic case that we can present with a project proposal so that it gets through? See, we need to ultimately have a 12% rate of return or 10% rate of return upfront written on the paper that we are moving for seeking approvals. So I want to have an answer to this. How do I do this economic justification right now?
Okay, the trick is that the answer will come from you only. But my suggestion is that you break this question into two parts. You know, there is a saying that good money will chase good ideas. Let's first use the program over the next 2-3 days to create the vision, the technical reason, the operational reason, and you know, really explore. As a student, we don't want to limit you in your thinking process. We want you to be able to visualize what's possible. Just a minute. I think I am also being bombarded with a persistent caller.
I think while Anup ji gets back, Utkarsh ji, आपने जो बताया, I think it's a very valid point, because बिना ROI का कोई भी project fly तो नहीं होगा. I mean, it is just not possible. So Anup ji is here. Yes, Anup ji, I think you can. So in my experience, one of the key things that you can focus on is to observe what is the losses that you are incurring in that particular process. जहाँ पे loss हो रहा है, आपका time loss हो सकता है, manpower loss हो सकता है, material loss हो सकता है, method की वजह से loss हो सकता है. If you are able to capture losses, I think the natural outcome is going to be translating it into ROI. So first and foremost, I think that is the first step. See if you can somehow get a very, very top level thumb rule kind of an information about where you're losing something. I think if that can be identified, nothing like it, immediately you can translate.
Okay. Yes, perfectly. You know, there is, just to build on what Kalyan said, either look at your pain points. Where you have pain, you are prevented from moving up the ladder. So that is opportunity loss. So if you're consistently having, breakdowns, definitely you are not able to sort of get your goals met, productive goals met, or your quality goals met. And depending on, what your customer requires, you're not able to give that kind of satisfaction. So those are some opportunities lost, some things to talk about. The other is where you are definitely being pulled down by one or two small elements, but you can clearly see the gain. So pain or gain in terms of operation, in terms of how your time is being spent. I'm jumping, but I wanted to say that it's Industry 4.0 beneficiary is not only the operation or the business as we see, it is also about us human beings. We have to be empowered to do what we really want to do and not being pulled down. Once you have this in place, we'll talk about converting it into an ROI or an economic value add in terms of opportunities. Now, just again, think back. And sometimes it's also better to, when you come to a course like this, not to be constrained only by your present environment in the railways. Look at that Adidas story, which Dr. Jha spoke about. What are they up to? They are up to creating a new benchmark for high performance shoes but customized. And we all know that if you're able to do any particular customization, you can get paid more. So what they did was they looked at the objectives of their customer. Somebody wants to win a marathon. Somebody wants to win a sprint. He has a different foot profile as compared to everybody else. So he needs something which is unique and which Adidas is willing to give him. And that shoe can be priced 10 times, 20 times, 50 times more for a champion. So depending on what are you serving, are you applying this technology in one of your world-class trains? Are you building something for the bullet train? We don't know, but start becoming a free thinker as far as this course is concerned. Look at the opportunity the technology does when you can marry physical world and cyber world. That's the bottom line. So what is it which is possible for you currently and in the future? Now, if we can proceed further, today you're at the end of day one. Tomorrow you will be getting more technical inputs. As I said, you'll be getting on sensors, you'll be getting on smart machines, you'll be getting more on IoT. So by the end of tomorrow evening, you would have got sufficient gyan on many of these aspects. I'm not saying you will be completely ready, but it's enough for you to use your weekend break, which is a Saturday, to try and identify the target machine. So you can come back with this free thinking, you can come back with all the learning which is there on the Moodle platform and start looking at how you are going to do this project ideation. Now, ideally, we would have liked you to form teams from within your unit. So where you are in a pair or a threesome, logically you should just combine and work on a project. It could be a bigger project than if you were to work alone, but more important, it also gives you access to sort of use different thought processes and build this together. For those who are the only participants from your unit, maybe you should flag that with Mr. Yagnik, and you can get somebody who would sort of pair up with you. Ideally, we would not want you to work alone. That's the thing. But if there is a rare case where somebody is alone, what I would urge is contact somebody in your unit and ask him to help you with data about the machine you have identified as a target. So somebody who may not have done the program can still give you some insight as to what the pains are and what is the kind of machine which can be worthy of being taken up as a project. So as I said, the project has to have two beneficiaries. One is the business, which we could even say is the main machine or the mother machine which you are taking, or the manufacturing cell which you are taking. Kalyan has already said that look at availability, look at performance, look at quality. And there would be perhaps a role for automation. If there is, do identify it. Even if it is industry 3.0, you still need some foundations for that. Another aspect of industry 4.0, which makes it different from automation, is autonomy. That you have empowered those systems in such a way that they can themselves exchange data and come up with many actions. So when that begins to happen, there will be only that rare data which needs to come to you for analysis. Again, you saw a case study where there was this accident taking place, and that correlation was not possible automatically till somebody had to look at a curve, think out of the box, suggest an idea and validate that idea. Now that is where you are really empowering the human being. And whether it is in the analysis of design defect, as happened in this case, or it is in the analysis of a manufacturing defect, that could be one area of adding to human power. The other would be decision making. Do I need to prolong maintenance of this machine, or do I need to start buying a new machine? Or it could be insight. If you remember, between data being available from an event to getting an insight as to what this happened, that is the curve which Industry 4.0 can shorten, and that's another area of human empowerment. But the bottom line, whether you are doing an improvement on the machine or you're empowering yourself, is always Industry 4.0 is meant to close the loop faster, close the loop more accurately, and close the loop in the first few tries. That really is what you should attempt to do. Anything which you have too much of data, but you are frozen into inaction, is not a great solution. You still have ways and means to figure out what is it which freezes the humans from acting. Again, look at some data which is relevant, which can unfreeze them, put it into the circuit, and then that becomes a closed loop control. You'll have to, I'm skipping making a presentation, but there is a 12-minute recorded lecture of mine, which is available in the Moodle platform. It'll be flagged for Saturday morning. So there's a audio recorded lecture of 12 minutes. Have a look at it. You'll get many more ideas. We've also discussed the team platforms. Now, just to add something more, on Tuesday, which is 1st of February, there's a formal session where we will review your progress. Now, that's the time we will give you some feedback. And if we find that there are common things, for example, somebody is working on a CNC machining line in one zone and somebody else is working in another workshop, we can also come back to you and say, do you want to connect and build this as a common project? So Tuesday, 1st February is going to be like midterm. Then on Thursday, which is the last day, you will decide one of your participants can become your spokesperson, and he will share the project summary with the entire class. We will be giving you a simple PowerPoint template, which you can anchor your presentation on. You'll also be trained in making an executive summary. So for answering that question, how do I get the big money sanctioned for my project? Many a times, it is the fact that we are not able to present the project in a way which is very exciting for the top management. So if you had to go to your railway board chairman or the member railway, mechanical railway board and give him a presentation, you'll probably be given just a few minutes in his busy schedule. How do you make it into an exciting possibility for the railways is what will determine how much money they will give. The ROI, as we said, will definitely be covered if you are able to address the specific breakdown areas and the specific, customer win areas. So with that, I request you all to get active on the Moodle platform right from this evening. There's a lot of homework Dr. Jha has given in the typical IIT fashion. He's making sure that all of you, emerge as champions at the end of this program. And therefore, this whole homework has been lined up for you. Please communicate using the Moodle app. I'll automatically get an email. Dr. Jha will also get an email and we'll be able to come back to you in time. If for any reason you are not able to connect with us, drop in a message on the WhatsApp. We are available on a daily basis to come back to you. So with that, I think, I would sort of end and hand it back to you, Amit.
Thank you, sir. I think let me just take this forward. So finally, we come to the end of the session today. I think it's a lot of good information being shared, and the project formulation is also being initiated by Mr. Wadhwa. What I will be just utilizing next 3-4 minutes to give you a quick glance on the FSM Skills website, maybe because some of you might not have logged in, and how to attempt and where the information is available. So just allow me to just share that information with all of you. So what you will do first, let me log out from this website. So once you reach out to this fsmskills.in, you have to just log in with your login credentials, which are being provided to you. So just I'm just logging in from my account to the website, and then I'll see this course. This is FSM Fundamentals of Industry 4.0 and Smart Manufacturing. Just click on the course, you will reach out to the content here. Now, as I was mentioning during the session, there are some of the activities you are supposed to do. So you will be at least finishing this part, which was opened yesterday, and now you can take it forward and then complete it. It's a pre-course assessment and Industry 4 readiness survey. These are just basic questions and basic survey that we require. After that, what I was just talking about to understand the overall scenario of the smart manufacturing implementation, there's a hypothetical case study being presented with the help of Mr. Samrat Kumar. You can find time and then you can go through this individual steps that are being explained over here. So some of the things I was explaining during my session, but again, you would like to at least review them in light of this discussion that is being mentioned over here. So how to start smart manufacturing, what is economic benefit, will solve my challenges, what is happening in my factory, how to know that factory is doing smart manufacturing, so maintenance issues, can technology help? So this is just a quick understanding you can have. These are the short videos that you can go through. Then these are the assignment that I was talking about in the session. So redefine the Industry 4.0 Samarth Udyog. So list 4 key improvements you look forward in your facility in next 5 years. That is what you are supposed to do. You have to just click this and then you can attempt this. Same is the Samarth Udyog vision statement that you can write down. So it is limited to 50 words only. So don't go beyond that. Vision should be covered within that statement only. Then after whatever we discussed today, there's a smart manufacturing quiz available over here. So if you can look at this at 6 today, it will be open and it will be available till tomorrow afternoon actually. There are hardly 8 to 10 questions that you are supposed to attempt. At any time you open this, it will give you 10 minutes. So the duration starts from 6 p.m. today till 12 afternoon. Whenever you start attempting this, you will be allowed 1 attempt. So you can go through the content first, what I was just mentioning to you. And then after that, you can attempt it so that you will get to respond to these questions. And once the moment you start, you'll get 10 minutes to complete this. So this is the way you can do that. So that is for today. Then there's a information on the IoT. If you have time, you can go through it. Otherwise, you can leave it. But at least respond to the IIoT survey. Actually, this is a survey where there are 5 questions only to be responded. These are generic questions, not too technical. These are more related to the business and operations. But if you can respond to that, we'll have some points of discussion when we take up the IoT discussion. There are some reference reading that I was mentioning during the session also. For example, if you click on the smart manufacturing reference reading, this is the Digital Factories 2020 report from which I have just taken that snapshot. This is a very good reading. Apart from that, there is a maturity index article that you can read. So I just compiled some of the information from various sources. If you can get some time to go through it, take your time. Maybe you can utilize some of the weekends time in understanding and going through it. More than that, you will also be getting upcoming reminders for the various things which I have configured to be started and completed within the time. So you can just see the time so that you will not be losing them. So I will also keep reminding you on WhatsApp group, but you have to start. So today's activities are clear that you have to do the assignment part. So short statement that you have to finish, then you have to do a smart manufacturing quiz, and you can participate in the IoT survey. Rest of the things will come up as we go along. So smart sensing session is planned for today, but still if you want to have a look at some of the basic understanding about the sensors, you will enjoy a session more once you are going through these basic videos. So the next session will be more on the application side. You will understand them better because these are talking about the basics. Then there is a sensor quiz which will start tomorrow, because once we finish the session only, then only it will be available to you. So even if you click today, it will not be giving you a chance to respond. So on as the session continues, you will find these quizzes will be available when the session will be over. And hope, I think today's assignment is clear to you. Then you have this course schedule available completely over here. Some of you might have gone through it. So in any case you want to refer to the schedule, you can just reach out to this place. You'll get all the information over here. Then we have also planned a course preparation part, self-study reference. So that is what you can do day one, what you can refer and what you can go into, that is being mentioned over here. So that will also be a kind of a helpful table for you if you want to go through the additional content. My suggestion again is that because you get this opportunity to go through this 18 hours training program, learning program, certainly all of you have even more serious engagement at your place, as Mr. Yagnik was requesting that please spare some time and make use of this opportunity so that we can be fruitfully conducting this course and helping you in understanding the subject. So that is all for today. And if there's any query or questions, we are happy to respond to that.
Can I